say hello to everyone?
Hello, test, test.
Yep, you're good.
All right, folks, good morning. Welcome back for day 2 of our Vendor Summit. Hopefully this time with non-crackly audio online. But thank you for being here. Our first talk today is from Ian Evans, talking about something I'm not familiar with. I believe it's a new venture for Ian, so I'll let Ian get started. So take it away.
Thank you very much. Thanks everyone for being here. So I'm going to talk a little bit about Beehive today and what we're doing as a company with it. There's been a lot of work that we've been involved in, and I'm very happy to share it. I'm also going to show a few demos so you guys can actually see something that's not vaporware and see how things are effectively coming along with the product. So I work for a company called Karios. I'm actually one of the co-founders. And what we have been busy building is essentially a new hyperconverged platform that has Beehive at its core. And really the focus is to try to extend FreeBSD and Beehive a little bit further into the data center. And really one of the big pushes is you guys have seen all the turmoil with VMware. You know, people are kind of moving out of those environments. They're trying to figure out what type of hypervisor they can use. And what is particularly frustrating in the market right now is there's not a lot of really good alternatives outside of your typical players, which is, you know, VMware, you've got Xen, you've got KVM, QEMU, and of course you also have Beehive. But if somebody's moving from VMware, they're faced with a few options. One is they can move to a solution like Proxmox or something similar, or they can move to another hyperconverged product, which would be something similar to like Nutanix or something along those lines, which is fine, but there's a substantial amount of cost associated with that. So what we're trying to do is really reduce the barrier entry in terms of the actual cost. We're trying to accelerate some of the open source adoption around the Beehive hypervisor, and then above all else, try to build something that actually has a user-friendly interface on it. Because we have, you know, obviously two different types of crowds, people that are fine working out the command line, working on the API, and then we also have people that really just want a simplistic interface as they move forward through the product. So we have a couple different approaches that we've really taken with the product, okay? One of them is we have a pure software offering, so you literally go in, you install FreeBSD 14.3, and then you run one script, and it essentially installs everything, and then you have your Karios environment up and running. So very quick, it takes about 5 minutes install. And by the way, I have a demo environment, so after this, if people want to sit down, they want to see it, you know, I've got a couple live environments we can go through, and we can show some of that stuff as well. And then we also have another product that we've been working on, which is basically a data center in a box. And what's pretty exciting about this is what it really does, it takes all the great things with FreeBSD, all the great things around Beehive, and it consolidates it into a small data center infrastructure that's extremely portable. It's about 12U in size. And we took a slightly different approach with this. There's a couple different deployment models we have. One is using very energy efficient NUC, you know, which you're probably familiar with, 4x4 NUC platforms, Intel NUCs, and essentially putting those in the box to the extent where you can build a cluster. Now, when you think about the cluster, there's obviously one major deficiency that doesn't necessarily exist right now within the Beehive ecosystem. So we are working on that. We do, in a couple months, we do anticipate a full distributed cluster that will be built and operational alongside of Beehive, and that incorporates Hashi Raft, and we're using etcd for that and a few other things. But that's quite an exciting thing we're really looking forward to pushing out. But the idea is you can essentially utilize low power NUCs. You can put a ton of them in the box, up to 40 of those in there, and then you can distribute workload across that. And then you'll see also, as I show the product, we have a Kubernetes deployment model, so you can actually deploy Kubernetes in a virtual environment. You can also deploy it on bare metal. So what we've really done is we've created this nice ecosystem where you can effectively go into the UI, you can quickly select OpenShift or Ubuntu Kubernetes or Google Anthos or any of those, and you can actually deploy them on Beehive, which is really great, and do things like PCI pass-through and use GPUs and all that sort of stuff. So a lot of really good stuff happening there. And then the other piece is we have another piece that we're kind of integrating. It's called PowerLink. And essentially what that is one of the frustrations I've had in the data center space is you get a virtualization platform, it doesn't really tell you a lot about power. And power is top of mind for a lot of people, especially in the data center space right now. If you go into where our corporate headquarters is in Ashburn, the power grid is strained. They can't put any more data centers in there. It's a big problem. So we address this by building a very agnostic product that basically goes in, and what it does is a transformer that plugs into or just clips around the hot wire. And then you can see on both ends, there's an IEC connection, which is standard for servers. You unplug your server cable, you plug that in, you plug this into the back, you scan a barcode, you scan the barcode in the back of the server. That associates, and then that actually pulls all the power telemetry directly into Karios, so you can see your exact energy consumption at the plug, and you don't have to worry about having to use a third-party piece of software, something clunky within a PDU. So why did we choose FreeBSD for Karios? There's a lot of reasons. One is I've been using it for a long time. I used to work for a storage company called Wasabi Systems back in the day. They were a big NetBSD shop, but that was my first exposure to FreeBSD, and ever since that period of time, I've been absolutely hooked. And the main reasons I've been hooked is everything that I've kind of put here. It's simple, it's performant, the storage is great, the community is really good, and above all else, I like it because it's a well-maintained operating system, and it is not a heap of distributions with a kernel. So we have all this going for us, and I think once we start to push bhyve further into the enterprise through this product, I think the adoption is going to be really good. There's just a few loose ends that we're working on. That's the clustering, some GPU support, and some other stuff. So what does our solution incorporate? First of all, it is considered a hyper-converged platform because we actually are starting to converge storage and networking into the product itself. And we also finished one major deficiency that I saw in most hypervisor platforms, and that is when you go in and you talk about security, there is always the patching piece. Patching's one piece, but what about compliance? So if you need to get a CIS-compliant FreeBSD install up and running, what's the process to do that? So we incorporated all the CIS benchmarks into here. We have a special tool. It's based on OpenSCAP, and what that basically allows you to do is pull in any DISA or Naval Information Warfare Atlantic. They have a tool called the SCAP Compliance Checker. It allows you to take those CIS benchmarks and all these other security benchmarks, your CVEs, import them in, and then you can scan the system, and it shows you exactly what the security posture is on your system at any given time. So for me, I thought it was a fundamental piece that we needed to add into a hypervisor platform to complete the security message specifically. The other one is we did address VM and container support. We are adding Podman support. That's very soon. We've just been waiting for that to kind of, now that the announcement is out there, that's great. But we do support Kubernetes and some other container installs like I mentioned. And then I mentioned about the Karios Cube. I won't go too far in that, just some size stuff. And then we also addressed one other major deficiency, and that is when you deploy a hypervisor platform in the data center, how much time do you actually have to spend touching the hardware? In my mind, you shouldn't really have to touch a lot. And to do that, you utilize a couple different methods. One is you can utilize the server BMC, the baseboard manager controller. You can connect to that, and you can deploy a hypervisor footprint, an ISO or you do Pixie boot. There's other ways to do it. But there is one area that was not addressed, and is if somebody wants to put FreeBSD onto smaller NUC-sized computers, which are becoming very popular for edge server deployments, they don't have a BMC. So how do you address that? What we ended up doing is we built a framework that allows you to take a pkgbase, which is basically a small, small KVM device, and you can attach the ATX front panel connector on it. So there's an Ethernet connector on it, and then you basically run that through the case, and then you attach it to the front panel connector, and that allows you to control power and reset and everything else. So we added that in there, and then we also added some deployment routines, which essentially means that you can now take, and once you go into Karios, you can deploy the hypervisor through the product. You don't have to touch the hardware at all, or at least very minimally, which is great at scale. If you're doing hundreds of servers, that's very, very important. So the other piece that we've been focused on is SDN. We initially used VM bhyve, which was great, and there's a lot of functionality in there that essentially allowed you to provision a switch. But when we think about a switch, one of the things that I thought was particularly important is that we also want to add some routing functionality in there. So if somebody wants to do things like set up a BGP, a network and connect a couple ASs, or they have to do OSPF, or they want to do VXLAN and they want to extend their VLANs across layer 3. Well, that should be in there. So we actually added in a fully operational SDN, which is based on the free range routing, or FRR project, which has been ported into FreeBSD, and it works quite well. Now, what we're doing here is we're augmenting that a little bit with VPP and DPDK. And what that's going to allow us to basically do is build something that's very similar to a distributed virtual switch. In order for things to cluster and that clustering model to work, you really have to have what's similar in concept to what VMware would say have with a distributed virtual switch, uplink ports and port groups and those sort of things. So these are things that we're addressing in there. We're adding into the SDN framework, and that's going to be an integral part of our product. The other one is, like I said, power management. I touched on it a little bit, but we did add a lot of analytics into the actual hypervisor platform. So what's nice about this is at any given time, as long as you have PowerLink enabled in there, you can go in and see your kilowatts per hour. You can see how much energy is being consumed. We also added in grid APIs. So if you have a power company API that's exposed, the idea is we can actually pull that in, and then what we can do is we can also look at the current power generation rates, and that would also expose the billing, and with that you can start to calculate the amount of energy that you're using and how much energy you're saving when you make certain system changes. And what's particularly important about this, especially for the strain on the power grids, is it'll get to a point where, let's say you have 200 servers and you need to filter those. What's my top talkers in terms of energy in my data center? I want to see those right now, and I want to see what that looks like. Well, you would go in, you'd be able to sort that. You can see your top talkers, and then you can figure out which systems may not be optimized properly, and then you can take remediative action on it. And we have also built in some tools that allow you to do exactly that. You can actually go in through Redfish, through a BMC, and you can actually set specific power profiles. So take example, if you have a system administrator that put a Dell R740XD server in, well, one of the first things a lot of times they do is they put it in high performance power profile because they don't want to touch it again. They want it running at the maximum speed. That may not be the best optimization pattern for that server based on the workload. So we built analytics in here that actually take a look at that, and it compares the workload to the power, and then it actually tells you and kind of makes a recommendation, like, are you making this the best use of this server, and how can you optimize the power? So we're trying to really extend the functionality and capability well beyond just giving somebody a hypervisor, giving them something that has things that matter to their business and that allow them to save money. So that's a big push for us. On the OpenSCAP piece, and I will show this in a moment, like I said, we pull in 2 benchmark profiles, one from DISA, the other one is from Naval Information Warfare Center. They have a list of those. They're very specific. It shows all the current CVE vulnerabilities that pertain to FreeBSD. But what we also did to make sure that this tool is more useful is we extended it out to the virtual machines themselves. So it can actually connect into an agent, and the agent is optional, but you'd put it in there. And then what that does, it establishes a secure control channel into that VM, and then at that point you can scan based on the profiles. So let's say you have a MySQL database, and you want to see if there's CVE vulnerabilities on the database. Well, you take that profile that you would download from one of those sites, you'd load it in the tool, and then what that does, it'll come up and it'll tell you exactly what's vulnerable, and it'll make recommendations on exactly what you need to fix. In some cases, you just cut and paste it over. It's that simple. So we really cut down the amount of time, and the big thing for us here was we didn't want a lot of guesswork on this. People are sick of using different tools. They're tired of it. They would like to see some level of integration that actually shows vulnerabilities inside of the hypervisor. So that's a big push for us as well. So on the Kubernetes side, there's several different deployment patterns that we enabled. And as everybody probably knows that deals with Kubernetes, it's not entirely friendly or easy unless you're using something maybe like Sidero, which tends to be much easier. So what we did is effectively up in the right-hand corner, you'll see it up there. You just select Set up Kubernetes. It actually brings a list down, and you can see OpenShift, and you can see Ubuntu Kubernetes, and you can see all of the different ones. K3s is a great lightweight one. And then it takes you through a step process, and then you actually create your Kubernetes cluster, and you're done. It's running on top of Beehive. It's also running it on bare metal. You can do a hybrid approach. And where that's critical is beyond just giving people individual Kubernetes deployments to deploy, we actually give them a service catalog. So they can select the one they want, and they can move forward from that point. So a couple high-level use cases. I'm not going to go too far into these, but we have really been focused on a few different things. One is with the box, specifically the data center in the box, what we want to try to do is get FreeBSD a little bit further into some of the edge markets as well. So a big thing for us is how do we take that, and if you put something like that out in the field, there's two barriers. One is communication. The other one is power. So what we did when we built the cube is we built it in a way that it can take standard DC power. You can plug solar panels into it, so standard 48 volt. And then you also have a multitude of connectivity options. So inside of the FreeBSD distribution, there's also a PPP dialer, so you can run cellular modems. You can connect those into any cellular network, and then also for backhauls, like wireless backhauls, extending that out, but actually building in automation and functionality. So when somebody adds like a radio, let's say, a PoE radio, and they're connecting a backhaul network, the moment they plug it in, there's some automations that take place. It builds a dashboard. So there's a Prometheus, there's like a node exporter that gives you statistic on your RSSI and your signal strength and everything else. And then you can effectively start using that within the field. So really trying to push it into those specific areas. And then some other command and control stuff, but that gives you an idea in terms of what that use case might look like. And you're talking about high bandwidth dishes over long distances, in some cases up to 80 to 100 miles. So it's very, very specific in that use case. So on the roadmap side, we have a lot of things going on. There's some very important initiatives that we have, some that we consider critical if you want to try to get FreeBSD and bhyve a little further into the enterprise and really kind of hit that consumption model where you're starting to carve into some of the VMware space and stuff like that. One is clustering. So as I mentioned, we are building that model through etcd and wrap. That's going quite well. We have a couple months of worth of work on that, but we're moving forward on that very quickly. The other one is on our SDN. We also want to support MPLS. That's very common with a lot of carrier-grade networks. People are using a lot of that. So beyond just normal internet access, we need to do that. And then the other one is kind of persistent things with GPUs. There's some resizable bar issues that are still persistent within bhyve. So if you put a GPU in there and you're passing it through to a virtual machine, sometimes you have to do manual resets and stuff like that because there's some issues with resizable bar. And then you also have the issue of addressable memory in that, in the BIOS itself. So that'll be fixed. And then the other one is some of the VDI stuff. There's no particular reason why bhyve can't do VDI. There's some things that can be done to enable that functionality and then start to add some level of virtual desktop infrastructure capability in that so people have alternatives in the VDI market. They're not just constrained into one or two. And then I'd say some other hardening support. We're working on a couple projects, with FIPS. So specifically, we obviously want to get this more in the public sector, and with that, there's some initiatives that we have to push forward to make that effectively happen. So yeah, that's kind of the product in a whole. This is the roadmap that we're going to be aggressively working on for the next few months. But we're very, very excited to start pushing it a little bit further into some of the spaces that are typically dominated by the big guys. I think there's a lot of progress that can be made there, and we've already started to move forward quite successfully in certain areas, especially at the edge when it comes to the data center in a box. That's very well received, and people are very much liking the lightweight nature of it and how fast things effectively provision and move and everything else. So I'm very excited about that. So with that, any questions? And I can go over a few screens. I can go over some demo stuff specifically, but definitely want to give people the opportunity to ask any questions about the platform.
Is there any chance to get a kind of free account for FreeBSD community or FreeBSD
commuters? I don't know.
Which now?
Is there any chance to get a kind of free account or subsidized account for the FreeBSD commuters for, you know?
Yeah. Yeah. No, I'll talk to you about that as well. Yeah. No problem. Mm-hmm. Alan.
Are there specific parts of this that you plan to contribute back to FreeBSD?
Yes. So obviously, given a lot of the work that's been done in the area right now, there's been a lot of eyes on the project. You know, we obviously have to figure out where we monetize on it, but the answer to it is we're coming out of that mode, kind of working, and there's going to be an open source push on various aspects of the project. So yes, that's correct. So we've already started to do some upstream contributions as well. So like with CHERI, some of the fixes on that and some of the things are being done there. That's been upstreamed. There's some stuff we've done with modems and some other things. But yes, so the core hypervisor piece, we have a plan and a strategy for that as we move out of the development of the project. Yes?
While you take other questions, can you go back to some of the use cases that you see?
Sure. Which one would you like to see? No? Yeah, so this one particularly, this one? Yeah, so this one particularly is where there would be a mobile data center deployment that would need to be rapidly deployed. So this kind of goes into like a model where you would have like FEMA, and they do a disaster recovery type thing, and they need to drop in a data center and it has to have critical services on it. That's where something like this would effectively come in. Drop it in the field really quick. You have the multiple connectivity options in there, connected through cellular, backhaul wireless. We actually have a Starlink PoE and functionality in it. We also have some gRPC stuff we built in for Starlink, so you can connect that into the product as well. But yeah, that's the use case for this, is kind of like remote connectivity there. Rural hospitals, this is kind of a big one for me. I used to work in healthcare for, probably 5 or 6 years. And one of the things that I found is deficient is when you get into a lot of the rural areas, a lot of the communication infrastructure isn't so good, obviously. So you still see a lot of older, decrepit infrastructure. And as a result, being able to drop something like this in that's small, they don't have to stand up a rack. They don't have to go in and retrofit an entire data center. They clear out a wiring closet, literally, and put an L630 on the wall, plug it in, connect the fiber uplink, and then they're effectively up and running, and they can start to focus on outcomes around rural deployments. So like remote CPoE, remote EMR, remote medical record storage, that sort of stuff, very specifically. And what we also did on this, so is we built a fairly substantial external storage framework within the product itself. So CHERI is one we've been very much focused on. So you can have some level of distributed storage within FreeBSD, and that's been fairly successful to the extent that you can deploy that as an alternative like CephFS or something like that. So we also have some object storage and some other things that we built into it as well that kind of like tie into this for like archival records and things like that. Security and surveillance, I mentioned that previously, but we also have been doing a lot of GPU work on the product. And as I mentioned, we're doing a bunch of GPUs as it pertains to the core Beehive functionality. But really what a lot of people want to do is they want to be able to stand up one of these systems, and then they would want to pass through a GPU, maybe build like a Frigate NVR or something similar, and then use that for streaming. So we actually started to build a service catalog into our product that you can go in and select a Frigate deployment pattern. You would go through that, and then it would effectively build it, and then you have your NVR, and then you can start to use it for remote video cameras and everything else specifically. So quite nice. The manufacturing, mining oil and gas is a pretty interesting one because one of the issues they have is when you put a temporary data center in there, one of the things that has to happen is they have to have communication down the tunnel. So in order to do that, backhaul wireless is very important. So when we built out the box specifically, it has a pretty extensive PoE network built into it. So you literally get power over Ethernet. So when you connect a dish, you plug it into the back of the box, it powers it, and then you can connect it down into the radio that's pointed at the mining site, and then you can effectively send the data down the tunnel, is the idea. And then they would have access into all the data center resources that are effectively running inside of that box, right? And then financial use cases and auditing, there's a lot of security stuff in there. So we've been very much focused on, PCI DSS, with healthcare, HIPAA, that's an important one. High-tech's another important one. If you go through Joint Commission in a hospital, it's an audit process that's very lengthy. We're focused on that as well. So with that security auditing tool, that's one piece. And then we also have expertise within the company too to help them if they put FreeBSD in, and they need some additional security remediation or they need to figure out best practices in security. These are things that we kind of integrate into that overall use case. And I just went through healthcare specifically. But on the power side, I didn't mention it, but LEED is very important for a lot of buildings as they start to get the green certifications or Green Building Council. They're also going to want to go for LEED certification. And what's nice with the product is when you go in and use it, you can actually generate a report. So if they come in and they say, what has your energy consumption been for the last 5 or 6 months? Go in there, it actually shows it, and then you can effectively start to utilize it right at that point and then reduce the amount of time that is required to audit those resources and so forth. And then government, that's kind of similar, a lot of compliance, FIPS, trying to get a lot of certifications and things that kind of get it into some of those areas that are required. But there's a lot of small data center use cases there, for shipboard systems and military hospitals and stuff like that. So that all kind of falls into that category as well. But what I can do, and John, how much time do I have?
You still got some time.
Okay. Go ahead and show you guys what it looks like here. Okay, so here it is, and I'll go through it really quick so everybody can kind of see it. So the first piece is we have what's called Karios Forge, and that essentially is, like I mentioned, its sole purpose is to make sure that you can deploy Karios quickly and efficiently within a data center footprint. So you would have all your resources, you can connect to those, you can deploy Karios on it quickly, and then move forward. So on the storage side, we've done quite a lot there. So MooseFS, I don't know if everybody's familiar with that one, but it's quite a nice distributed file system. It has a paywall on it, but it's very well integrated to FreeBSD. It works very quickly. So we did do some MooseFS integration there, and as a result, you can go in, you put your MooseFS cluster information in there, it connects to it, but what's nice about it is also allows you to manage it. So it does some lifecycle stuff as you go through that specifically. And then we also support S3, so if you want to connect to an Amazon S3 bucket, for storage and you want to put archival data in there, that's there. And then we also have all the typical ones you'd see, iSCSI, NFS, SMB CIFS with Active Directory integration, that sort of stuff. On the network side, all virtual switch functionality you normally see. So what you're seeing here is kind of artifacted VM Beehive, and that is where you'd actually have a standard virtual switch, but you also have a Veil switch in here. And then we have the SDN piece, which is much more comprehensive than this. This is just kind of the basic one. If you want to get started, just create a simple virtual switch. You would do it in here, creates a tap interface, and then you can go in and assign it to a VM. So very quick process there. Event logs, this is one that I always personally annoyed me a bit, sometimes it's really hard to get logging information. So not only we put it in one area, but we also color-coded it. So if there's an auditor and they're not necessarily familiar, they can see what is successful and what has actually failed. And then you can filter this very specifically. So if you want to see what's going on in ZFS, you click that, you can see all your ZFS logs there. So quite nice. On the stats side, this is basic. It just shows all of the nodes that are connected, and it shows the overall utilizations. And then you can also see power-specific data if there's a PowerLink device attached to it, which shows watts, voltage, and kilowatts per hour.
Question?
Yes?
If you have 0.46% CPU, it must be on. Why is it probably 0?
Which one? Oh, it's probably a lab one that we're working on. Yeah, and then release management. We have that pretty well built, so you can do all your release updates and do all your release management stuff here. You don't have to drop down to a shell or anything like that. It's pretty streamlined. And then when you go into the node specifically, there's a lot more information here. So you'll see a few things here that are specific. So you'll see the typical stuff. You'll see your CPU utilization, your storage, your memory utilization. You also see the efficiency score. So what the efficiency score is, it looks at things like workload to power consumption, and it compares those, and we have kind of our own algorithm in there, and then what it does, it gives you an actual score. And what's nice about this is that, like I said, if you have a lot of servers and you're trying to figure out which ones are energy efficient, which ones are not, you can go in there, you can filter those, and then it kind of keeps track of that. So again, it's just a push, try to get to a more of a green, type of mentality, as it pertains to infrastructure, because there's so much around power utilization and power consumption right now. So very much focused on that. Now the other thing is you'll notice there's a lot of information here. We tried to make it as rich as possible. So you can see all your devices at any given time, all your PCI stuff. You can see the power consumption right here, and that's dynamic, so you'll always see that being updated if a power link is attached to it. And then we also have things that are kind of left out in some other products that are frustrating, like you should be able to see your disk stats, and you should be able to see smart status on your drives, and what does your wear level look like? Do you have bad NAND on your drives? So we actually provided all that information here, and that's tied into an alert system that we actually have built out, which is quite nice. Remote console. So if you want to get in the VM that is running the system, you can do that right there. The other one that is incredibly annoying is, why do you have to drop down 5 levels to put a ISO into a virtual environment? So we added that to the tab right here. You just go in, you put the URL in for the ISO, download it, or simply upload it here, and then you're done. And then you can attach it to the VM. The other one is PCI pass-through. So we have that working fairly well in here. So you can take any PCI device as long as it's fully supported. And then you can add that, and you can add that into the VM, which I will show you in just a second. And then we also put a lot of time and effort into ZFS, because I consider it foundation and fundamental, and it is a great file system. So we wanted to highlight what it does and make sure that we incorporated all the features in there. So you can go in, you can adjust your ARC cache here. You can go in and do things like add your data duplication, your compression. The encryption piece is there. You can do instant snapshots. That works quite well. And then you can also create pools. And then in here, you can select disks if they're available. And you can create Z-RAIDs and D-RAIDs and a bunch of other stuff. So it's very, very functional in that regard. And then over here, you'll notice that you can also add slogs, and you can add L2 ARCs. So if you do have to do secondary caching, it has the capability to do that in there. You can select that and actually build an L2 ARC device on a high-speed NVMe drive if you'd like. Monitoring, very, very specific here, that it covers the CPU, the memory, and the disk, but you can also expand this. This is just kind of the start. And then with PowerLink, this is kind of cool. You can see all your power stats for the hypervisor itself. And you can see the current amps and the kilowatts per hour. Everything is listed there. And then additionally, you can go into power monitoring. And it'll take a second for it to refresh. And it shows the power supply there. You can see all the statistics on the power supply. You can see your current utilization in terms of the cores. And then down here, you'll notice that it gives you some information on the workload efficiency, which ties into that score. Now, what's nice about this is you will see it says power profile recommendation. If the server supports it, you can go in, you can change that, and it actually makes a redfish call into the BMC, and it will change that power profile and readjust the power to a specific pattern that might match the server workload a little more. And then we also have some analytics in here that pulls all the billing information in, and like I said, we do grid ties on that, and then that gives you a bunch of information in terms of how much you're saving. Yes?
Repeat the question quick. Is it a new thing with newer servers Is this a newer thing with servers that the BMC actually knows the exact power supply plugged in? If you scroll back up, how does it know it's a titanium?
No. So there's a couple things with that. So if you have, like with the OCP ecosystem, you have the concept of a power shelf, right? In some power supplies, you'll actually have some telemetry on that. So if you have a system like that, you can actually pull that information in. Now, if you don't have that, it'll show the power link information, which is the device that's actually plugged in. That'll give you the power supply consumption. Now, if you don't have that information, it's actually quite simple. You just go up here, and then you can put all of your information in there, right? So a little bit lengthy, but at least we add the option, where you can put in your statistic, and then once it's in there, it'll automatically do the calculations for you, basically.
In this case, was this telemetry, or you manually put this in?
So this one right here is a manual entry. Yeah. Okay. And then on the network side, virtual switches, which I explained before. We also have a firewall builder in here, so if you want to add your PF rules in there and you want to add options in there, you can do it very quickly here. One of the things that we did do that was kind of annoying previously was if you fat finger a firewall rule, you lock yourself out of the box. It actually goes in, 60 seconds later, it reverts it back to the previous rule, you're back into your system. So kind of a simple thing. Now a shield, so this is the compliance piece of it, and what this basically does, like I said, is it pulls in those CVE databases, and what it does is it categorizes the vulnerability severities here. So if you've done any type of stigging within the government before, at any time, you'll notice there's a Cat 1, a Cat 2, and a Cat 3 vulnerability level. Now the Cat 1 is obviously something you want to address fairly quick. Cat 2 is important. Cat 3 is a little more informational. But the idea is here is I can click on that at any given time, takes me down here, shows the exact vulnerability, CVE. It shows the severity, and it also gives me the actual CVSS score for that, so you can see how fast it really needs to be fixed. And then we also have remediation information here for each one of those vulnerabilities. So you can click that, and then you can paste it into a command line, or you can see kind of what's going on there. Yes, question?
This is at the hyper-converged level, correct? Not actually guest level. You're just showing
So,
at the.
great question. So this one specifically, yes. However, the next release will have, I mentioned before, the connectivity that you can put an agent in there that'll connect into the VM. That'll allow you to actually put in the specific DISA and NIST specific definitions in there, load those, and then it'll scan the operating system on the guest as well and then give you a score. Yeah, exactly. And it'll give you the same type of thing here. And then we also have our own security staff. So we check this every day. And any new vulnerabilities that come out in the FreeBSD ecosystem or elsewhere, we put it in here and we track it by 3 different categories. There's CVE, CWE, and then we actually do a score there. So we try to keep that as specific as we can.
For the dashboard you just showed us, you're just pulling down the NIST or the MITRE data as far as the CVSS score?
Yeah, so it's essentially they have a bundle, and it comes in usually like a zip format, and then there's a XDDF in there, and then you can pull that in. And
but
then
I'm saying
once you do
you're
that,
taking their scoring, you're not doing your own scoring.
So that K vulnerability there is a combination of ours. We actually have one that goes alongside of that. So if we see a vulnerability or something that's specific to something we built in the product, that goes into there, and then that gets added into the aggregate score.
What version of CVSS are you doing at this point? 3 or 4?
On the CVSS, I'm not entirely sure. I can look and then let you know after. So on the security side of it, once you have all that information in there, you can go into history. And then up here, it'll actually give you a score. It'll tell you kind of like the history here. It'll show you who remediated what, and you have a complete log. So it's kind of nice in that, if you have a compliance auditor that comes in and they want to know, what in the last 3 months, what vulnerabilities have you closed? Run a report. It'll show it all right there, specifically. Okay. Logging, event logging, that's all pretty specific. Now to set up a VM, very straightforward. We just select the server. And then I'll select EFI. I'll go ahead and do Linux or BSD. Do 2 cores. Let's do 16 gigs of memory. And then in here, we'll go ahead and select the Z pool. I'll go ahead and do the VirtIO net driver. Public switch that I've created. That's it. That's all is required to create a VM. Now, the next thing you need to do is attach an ISO, right? So you'd come down here, and then you would select, let's say I want to do BSD. I want to start that VM up. I'm going to go and attach that. It's going to go ahead and build that that image. It's going to attach it. You'll see it over here. It'll start it. Give it a second to come up. And there you go. That's it. So you can do that. And by the way, everything that you see in here is API for everything. So if you can do this in the UI, you can do it to the API. You can walk that API. We have everything in there for that. So that works quite well. You can snapshot from here. You can see the activity logs. All the Beehive logs are here. We also do support cloud init creation of virtual machines as well. So if you're doing Kubernetes, it's pretty common. You can do cloud init. And then here, you can also do OpenShift, Ubuntu, K3s, or Omni, like I mentioned before. And that actually takes you through a process of walking through it. And once that Kubernetes deployment's there, you would actually see everything right here. And you can see all your cluster nodes. You can be able to click on those. And then that will actually bring down any VMs that are running in the environment. And then you can see all the information on those specific VMs and so forth. So pretty comprehensive there.
Quick question about the automation, API, Terraform.
Yes.
Ansible, you know it.
Yeah, so we support, well, because it is a standard REST API and you have accessibility into that, if you want to use Ansible or Terraform or Salt or whatever you'd like to use, you can effectively use those tools. It's not a problem at all. In fact, we use Ansible a lot in the product for core functions and other stuff. So it's a very common use case. Any other questions on the core of the product? Like I said, if you guys want to do walkthroughs or demos after, I can sit down with anybody or we can go over the product. That's perfectly fine. But I at least want to give people an idea that it's not vaporware. It does exist, and it does work quite well.
If we still have a minute, can you show the Netbox integration that you did?
Yeah, so on the Karios Forge, let me see if I have. That one I will show you after, because yeah, I will need to show that to you in a separate demo. But so what he mentioned on Netbox real quick, so what that is for single source of truth. Everything that's kind of in the product, because when you start putting in the data center, you obviously want as much reach into as many devices as you can. That includes power panels, power pass, IPAM, all that stuff. A really good way to do that is to integrate it with Netbox. And Netbox is used within a lot of data centers, and that provides kind of a single source of truth or information on everything. And that also allows us to be able to aggregate that information, and then it helps us for things like if you need to provision something, or you need to find something, or you need to deploy a workload. It's having that level of information at your fingertips is very helpful. Perfect. And I have your name up there on the tab. As we were passing the books out in the office, so everybody got one of your books, and it's been fantastic. Everybody's been reading that. Yep.
Another question about scaling. So how can I scale, in case I want to, increase the power of my instances inside your cloud?
So we have the basic concepts. If you go into a VM, you'll notice here that you can update resources fairly dynamic. Right now, obviously, if you want to scale out, this is where I was mentioning some of the cluster work that we're doing. That's going to be the integral piece to that, right? So you can do some distributed scale. So that's something you'll see very shortly.
About logging, so we saw this kind of event logging, like, I don't know, Windows style or something like that. Can I see the raw logging? I mean, just the...
Yeah, and I can, after this, I'll take you through that.
All right, thank you.
Any other questions? And by the way, there's the cube. If you guys want to see it, it's live. This is kind of one of the prototypes that we're working on, but pretty cool. Here's the Nooks right here. So those are your 4x4s. Those are all running Karios, FreeBSD at the core. We have a nice little display here that shows all the flow rates and all the specific information. We have a liquid cooling system that's in there. So when it gets deployed in the field, you can put it into an area that's relatively hot and actually will self-sustain. And then we also have a cellular module and a bunch of other stuff in here, but that's actually a working one. And that one is now running off 120, but successfully yesterday we tested it with a 100 Ah battery, and it runs no problem off that single lithium-ion battery. So it's quite efficient. But and also it's got insulation up here. So if you put it into an area where it's relatively hot, you'll actually get the installation in there as well. So it's a pretty cool design.
What's the box on the right?
Which one?
The middle right?
This little blue one? Which one?
No, higher.
Up here?
Higher. That one.
That's the cellular mode.
No, up one. The thing just barely.
Oh, that one? Okay, so that is actually a Minisforum node. Minisforum. They make like small form factor nodes. What's nice about those is they're really good for FreeBSD because what they do is you pop this chassis off on the bottom. They actually have usually 4 M.2s on there. You can build a nice little ZFS storage cluster out of those. But they also, what's nice about them is their size, and they run 18, 19 volts. So not a lot in terms of watts, but they have actually a half-height slot in there, so you can put in a high-power GPU, which is great. So if you don't want to run AC in something like that, you can run DC on it. You can put a nice GPU in there, and then you can actually use it for GPU workload.
How field serviceable are the parts? It looks pretty compact in there.
Yeah,
And
so
then
the answer to
also-
that question is we have a standard manufacturer we're working with on that, and that is kind of, as you saw, a prototype, right? But there's all of the parts in the new version are field replaceable. So you can slide them out. They got buckles on them. They slide out either on ball bearing, rails or something similar. Then you can unlock it and move them out and stuff like that. Like all the loops themselves have quick detaches on them. So all of it will be field serviceable.
And then follow up, power redundancy. How is that handled?
You said power redundancy?
Yeah.
Yeah, so on that box, there is actually dual path power on it. I don't have, I can probably show you the back. I don't have it on this one. But we also have dual network redundancy. We have network redundancy built into the box as well.
Other than 86 platforms like, I don't know, RAM or RISC-V, so what about that?
Yeah, so we don't have an ARM build right now, but because ARM is more of a first-class citizen now within FreeBSD, we are planning on doing some work around ARM. But right now the focus has been x86 just because of general availability and in some of the small form factor work that we're doing as well. So, any other questions? Perfect. Well, thank you very much. I appreciate it.
Thank you, Ian. All right, I think we have a break till the top of the hour, so there's probably still some various beverages and breakfasty things probably available over in the side channel. So we'll be back at the top of the hour. Or bottom of the hour. I'm off by a half hour. What else is new? Yeah, 10:30.
Say hello.
Test, test, test.
Okay, folks, if we can make our way to our seats, we'll do our next talk here in another minute or so. All right, everyone. For our next talk today, we're going to have Colin Percival, our release engineer, talk to us about other things in FreeBSD 15.0 that I think aren't features necessarily, but things that are going on in Colin's world and navigating our community through the process of our next major release.
Okay, mic's on. You can hear me? Sounds good. Okay, so yeah, FreeBSD 15.0 is sort of my life at the moment. Package base and no builds are really the big things going on here. So just by word of introduction, a lot of you know me already, but if you don't, I've been FreeBSD developer since January 2004. I spent almost 7 years as security officer. Very glad I don't have that job anymore. I started getting FreeBSD into EC2. As soon as it was announced, I emailed them and said, hey, I want FreeBSD in here. Why are you only running Ubuntu? Took a while, but I got it in there, and I've been maintaining that ever since I got it running. Because I was doing a lot of work on release engineering on the EC2 side, Glenn asked me to join as deputy release engineering lead in 2020, and then I took over from him in 2023. Because I got FreeBSD running in EC2, they decided to give me this label of Amazon Web Services Hero, which means things like they invite me down to their annual conference in Las Vegas. But I am not employed by, and I do not speak for Amazon. Also, I have a lot of NDAs with Amazon, so some things I can't talk about, but I don't think there's anything particularly relevant to this talk. So, EuroBSD 24 last year, I'd been in the job for about 9 months at that point, and I said, I've decided what I want to do as a release engineer, which is I want to make FreeBSD releases boring again. If releases are exciting, it means there are problems that need to be fixed. Ideally, developers shouldn't really be worried about releases. They just know releases are happening, and users should know that there will be another release coming soon and just go ahead and use the next release. We had very sporadic releases. The release cycles tended to drag on for a long time. So I shortened the release cycle from being around 4 betas and around 4 release candidates to just 3 betas and 1 release candidate usually. I mean, it sort of makes sense if something is a release candidate that, in terms of English language, means it is a candidate to be a release. So if you're putting 4 release candidates on the schedule, I don't know what that even means, really. Mind you, I did do that for 15.0, but leaving that aside. I announced a quarterly release schedule. Once I had shown that we could do releases in a reasonable amount of time, I figured we could do a new release every 3 months. And we have 2 stable branches, so alternating those, each stable branch gets a release every 6 months, typically. So the first month of the quarter, I'm sort of sending out emails saying, hey, there's a release coming, get your stuff into the tree. The second month of the quarter is basically full of betas, 3 betas and a release candidate, 4 weeks, that basically fills that second month. And then if everything goes well, early in the third month of the quarter, we have the release. If stuff happens, there's a security issue just before the release, it may get delayed, but it should still land within that quarter, before the end of the month. Every odd year in the second half of the year, I allocated that for doing a new major release. So we've got 2025, we've got 15.0 coming out, and the entire second half of the year has been doing that. So we didn't have a release in September, but in March we will have 14.4 coming out next. Point of this is releases are frequent and predictable. So people who are using FreeBSD, whether it's system administrators at universities or people building FreeBSD into physical products, they know when the next release is going to be. They can look at their calendar for when they need to update systems outside of term time at university or when they're going to be shipping some piece of hardware and know what release is going to be available at that point, know when they need to be getting their code in. And on the other side, it also means that maintainers of drivers, we have a lot of vendors, network cards in particular. They have updated drivers all the time, and they now know when do they need to get their patches into FreeBSD to get into the release. So I started looking at how does 15.0 compare to previous major releases. Now, development starts off on the main branch, and then at some point we create the stable branch from that. After some period of time from there, we create the relang branch for that particular release, and then it gets tagged as a release, ultimately. So I looked at what was going on between when we branch stable from main and when we create that release branch. During this time period, it's changed a little bit between major versions, but for 15.0, recently this has been sort of alphas for the releases. So in 11.0, we spent 5 weeks between creating stable 11 and creating relang 11.0. 170 commits went into the tree there. 12.0, 107 commits, 13.0, 142 commits. 14.0, actually very quiet, it was very short, 39 commits. 15.0, we've had 561 commits. So that gives you a sense already that there's a lot of stuff happening right now. I also looked at between when we create the relang branch and when we actually get the release out. So we're looking at 270 commits, a high of 405 commits for 13.0, 154 for 12.0. And we're at 821 and counting. So again, there's a lot of stuff going into 15.0, a lot of changes happening closer to the release than I would like. I sent out emails over the summer saying, hey, there's a release coming. It's time to get your code into the tree. And a lot of people did get code into the tree. The build was broken for several weeks because people were getting code into the tree. There was 1 week, I think it was middle of August, where I was doing the builds of head, and there were 4 separate issues which made head not build. So I had to, it was in fact the 5th time that I tried to build the 15.0 current image for that week that I finally got that snapshot built. But this was good, and I said at the time, if people are breaking the build now, they are not breaking the build in the middle of the betas. So it is good that people are breaking things over the summer. But again, a lot of stuff was going on. Now, the job of release engineer, I've said a few times, I'm fundamentally a project manager. I'm not a jack of all trades. I do not know all the code in the FreeBSD source tree. I've been a developer for 20-something years. I know a lot of the code. When I was security officer, in particular, the job of security officer is great if you want to learn all about FreeBSD, because stuff happens in random parts of the tree, and it's your job to fix it. And so you go onto IRC and you say, hey, can somebody tell me about blah? And immediately, whoever knows anything about that is like, OK, if Colin's asking, there's a reason. It is very important I tell him about it. So it was great for learning about things, but still, there's a lot of stuff in the tree. I do not know about everything, and I cannot fix everything. If I'm debugging somebody else's code in the middle of the release cycle, something went wrong, because it's your code. You should have gotten it fixed. If I'm stepping in to fix it, it means you're not fixing it fast enough, or you committed broken code and then you went on vacation. It happens, but again, it's that something went wrong if I'm fixing stuff in the middle of the release cycle. Ideally, during the release cycle, the only commits I want to be doing are things like bumping the version number. There's a bunch of sort of routine commits that happen. If you look at the commit log, you'll see there's the same commits for every release. And in fact, when I took over as release engineer, I was looking back at what commit did Glenn do at this point. OK, just take that and translate it directly into the new branch. In 13.3, I only did 5 commits between stable 13 branched and 13.3 release coming out. You can see the numbers here. 14.2 was a particularly difficult release. A bunch of stuff. We were landing OCI containers at that point in 14.2, and I did a lot of work to get those into shape, get everything fixed in time for the release. Fortunately, that particular time, Amazon was sponsoring my work on EC2 and release engineering, so it was nice to get paid for that work. But generally, between 5 and 20 commits that I've made during the release cycle. Well, I'm currently at 71 commits and counting. So this has been a lot of work for me. And in particular, it's been a lot of work for me going into fixing things that other people have written, because this is not just routine bumping version numbers commits from the release engineer here. So what went wrong here? Well, January 2016, there's an email to mailing list saying, subject, packaging the FreeBSD base system with package. We are planning on packaging the base system with package for 11.0 release. This was almost 10 years ago now. And I couldn't find any mention of it, but I do have a vague recollection of people talking about packaging 10.0 release with package as well. But in any case, it's been coming in the next major release for basically a decade at this point. So last year at EuroBSDCon, new release engineer, I'm brave, I'm foolish. I decide I'm going to get things done, and I say, OK, it's time to stop talking about this. Let's actually make package base happen. We're going to do it in 15.0. And that was fine, except in January, work started on the Zero Trust builds. Funded by the Sovereign Tech Agency. I'm very happy they gave money to the FreeBSD Foundation. I'm very happy that this work landed. But having package base and no root builds happen at the same time has caused problems. A lot of the late issues we've had have been because of interactions between those two systems. Package base, we are installing things differently. Everything's being installed from the package manager. No root builds, we need different things as part of building images. All of the VM images are built via a metalog file, which records what needs to go into the disk image. And so if you've got package installing files but not actually recording them in the metalog file, you get a disk image without those files in the disk image. This has given us a remarkable variety of fun bugs, like VM images which have etc/master password, but do not have etc pwd.db or spwd.db. So you've got the master password file there, but you can't actually look up any users. The following week, I found that I could not SSH into EC2 images. The password file was there. SSH was running. The user had been created properly. I went through the serial console on EC2. And I found that the problem was that we had 000 permissions on /. This does not go very well, because SSH was running as root, but then as soon as you try to connect, it spawns an unprivileged process for checking whether you can log in. And so as EC2 user, it was trying to read EC2 users' authorized keys, which of course it couldn't do because it couldn't read anything on the file system. And the reason for this, of course, was because / was not recorded in the metalog file. And so when Makefest went ahead to create the file system, it just said, well, anything that's not recorded here, I'll just create directories with default permissions. Owned by root, owned by wheel, OK, that makes sense, and permissions of 0, which is not so useful. Well, things are getting there slowly. 15.0 beta 5 builds finished a few hours ago. I had them running overnight. Once FreeBSD update bits are in place and all the images have gone out to the mirrors, I'll be announcing it later today. Release candidate 1 will happen November 14th. I will be surprised if it ends up being the final release, but it is possible. So I'm going to call it a candidate to be a release, even though I'm doubtful, but I'm hoping everything will be solved by then. We'll probably end up doing a release candidate 2 the following week. It's possible I will do extra release candidates. Usually I do 1 build per week every Friday morning. It's possible I'll do extra release candidates in here because we want to test package-based upgrades. And if you want to test upgrading from something to something else, you need to have something and something else. I really want to do the release builds on November 28th and announce them on December 2nd. That is the schedule that I set about 9 months ago when I put it onto the website. It also just fits into my personal schedule. I'm going off to Las Vegas for reInvent the week of December 2nd. So I don't want to be dealing with last-minute stuff while I'm already in Vegas. If we manage to land this on schedule, it will be thanks to incredible efforts from a lot of people, but I particularly want to call out Lexi here, Ivy who I mentioned I did 71 commits. She did 97 commits. And almost all of these were fixing stuff in package-base, putting things into the right packages, fixing dependencies between packages, documenting what the packages do, because at one point we didn't have any descriptions for any of them. So she's been doing incredible work on this. I really need to recognize that. So what's left in the release? At the moment, we do not yet have a package-based repository. There are package-based repositories on package.freebsd.org, which are daily update builds, rolling updates, but we do not have, say, 15.0 beta 5 anywhere. If you download the beta 5 boot-only image and do a package-based install, you will get whatever the latest nightly build is. We need HSMs to sign the package-based repositories. I've been talking to Gordon about this. If we do not, the foundation actually owns HSMs that are sitting in a data center. They are not yet set up for us to use. If they do not get set up for us to use, we will probably be using Amazon Key Management Service for this, possibly generating keys and then importing them into KMS. But in any case, we need something to sign the package-based repositories. I have code for building repositories. I just need to actually be able to sign them. As soon as I've got that signing dealt with, I will be pushing all the repository bits into Amazon S3 and then putting CloudFront in front of that, because I'm an AWS hero. Amazon gives me plenty of free hosting, and that is just the easiest way for me to do it. I can do it myself and not bother with cluster admin dealing with anything apart from a couple DNS entries for me. That has been a big blocker for other things. As soon as that is done, then BSD install can point at it so that the RC1 installer will actually install RC1 and not whatever the latest nightly build is. Mark can teach FreeBSD Update how to use pkgbase to do updates and also upgrades to future releases. And then we have a few minor issues that didn't quite get into Beta 5. Mark has a patch which fixes some boot failures with virt.io. I'll be merging that as soon as Beta 5 is announced. Bjorn might have a fix for some issues in RTW88. Apparently he was having issues connecting to networks, although maybe it does connect, it connects very slowly. I'm not sure what the current situation is with that. I told him he's got like 2 days before I just cut him off for that. We're currently at 2.4 RC3, I think, for OpenZFS. We might get one last update from them before we sort of fix what's in the release. The DVD images for AMD 64 ended up being 4.9 gigabytes, so we'll trim a couple packages out of that. It's important that these fit into 4.7 gigs because some people actually do use physical DVDs. Most of us just use memory sticks, but yeah, some people do actually want to use DVDs and want it to fit. There's this issue that was opened, bug that was opened earlier today about ESPs being created as FAT16 instead of FAT32. It sounds like it might actually not be an issue. I'm going to let Warner figure out if we need to do anything with that. And then more stuff might happen in the next couple of weeks. But you can see this list is relatively short compared to, if you look at things that have been fixed in Beta 5, it's like 30 entries there, and another 30 were issues fixed in Beta 4. So we're getting a lot closer. At this point, the default answer to any other merge requests is just going to be no. Like, if you've got something where the system does not boot, we'll talk about it. But if it's, I've got a minor bug in this utility, you can wait. We're going to have more releases. I'm not going to hold the release up for minor stuff at this point. We've got a long list of not being fixed in 15.0 issues on the wiki page. Most of these are new features that people told me months ago they were hoping to get in, but stuff happens, and it didn't get it in time. I'm not going to wait for them. And then I also have a long list of things that need to be fixed before 16.0, which is mostly issues with the build process. Like, I do not want to have the build process spend an hour building Git and a million different Python dependencies of Git. I'm going to put GOT into the base system. The release builds will use GOT. Also, I want package in the base system because package being in ports is a problem. 15.1 is scheduled for June 2nd, 2026. It's not on the website yet, but that's when it's going to be. I'll be sending out an email to people in January about that. But based on the schedule that we've gone with so far that generally works for minor releases, that's what it's going to be. So stuff that's not fixed in 15.0, you've got 6 months. It will be coming. And when I say you've got 6 months, I mean developers have 4 months because I want it in at the beginning of the release cycle, not at the end. That's all I have. Any questions? Microphone is at the back. Alan.
Since you've made the decision to get package into base, what are your thoughts on doing the same with Pudrere to give us more build tools for building images and cloud images and the packages themselves and so on?
What are my thoughts on Pudrere? There are things that I would like to get changed in Pudrere. In particular, I want to have Pudrere launching VMs rather than using jails for security reasons. I do not like the fact that all of the packages that we ship are built with no VM isolation between them. So yeah, as far as Pudrere goes, it might land in the base system at some point, but it's not a high priority for me. And in terms of anything that happens with Pudrere, my priority is making Pudrere better rather than bringing it into the base system.
I have a comment, and maybe it'd be a discussion or whatnot. I've mentioned to you on IRC that you're now following the NetBSD model for release engineering, which is where we mentioned to you the commits we'd like to see in the rel-eng twig. I think that's working great personally. I think it allows you to schedule your build, or I want this in, or after a build. What are your thoughts on how well it's working, or anyone else in the room? Like I said, I think it's something we should have done a decade ago.
Yeah, so the way that we were doing it until 15.0 is really a legacy of development on CVS. There was no CVS cherry pick command. Maybe we should have started doing something like that with SVN actually, but there's a lot of inertia in the project, right? I agree that this seems to be going well. That said, it would have gone better on the minor releases than on the major with 15.0. I mean, just looking at, where's my list of commits here? I've been doing a lot of cherry picking, let's say. There would have been a lot less cherry picking for me to do with past releases.
Yeah, I wondered when you showed that if that was things you authored, or if the 821's the cherry pick. And same for 14.0, is the 361?
So this is the total number of commits between, and yeah, if you...
go back to there was one where you had the Collins commits.
Oh, yeah, these are commits that I authored.
Okay.
Yeah. But yeah, if you compare, I did have a page here with commits between rel-eng branch being created and the release, but if you just compare these, you'll see that it's usually like around 100 commits that go into the rel-eng branch, and it's considerably more this time around. And on the minor releases, it's usually like 50 commits in total on the rel-eng branch between that being created and the release. Often there's like 2 or 3 commits between each beta, as opposed to 50 or 80, which you had this time around. So the cherry picking will be a lot easier for me to do when there's fewer commits, but absolutely it has been a lot easier in terms of scheduling the builds, where I don't need to worry about, I've approved this, is this guy awake? Is he going to commit it now, or is he going to miss the deadline for it? And you know, hey, does anybody know if this guy, what time zone is this guy is in? Anybody got his phone number to call him up and tell him to listen to the tree now? That said, there have been a couple times where issues with package base have needed to get fixed before the next beta, and so I've been talking to Ivy late at night, like okay, I'm gonna hold off on this commit on the builds, let you get that last commit in, but that's partly just 15.0 is a big release, much more than a regular major release. A lot of people have been saying, and I agree with this, 15.0 is really the most major FreeBSD release since 5.0, since when SMP landed.
I'm going to preempt everybody for a second since I have the mic, because of a follow-up. Of the 71 commits you've authored, which I think is the right stat, like the right way to count, so I was going to ask that too. How many of those would be something under like release itself, like the top-level release subdirectory in the source repository, versus you're having to fix something outside of the release script process?
Probably at least 2/3 of these are in the release process in some way. A lot of it is stuff like we're not correctly locking stuff in metalog, so I need to change the code for go into the EC2 configuration, a VM build configuration, and manually add a few files that aren't being recorded correctly, that sort of stuff. So yeah, it is release engineering stuff, but it is not
Mechanical changes.
Yeah, it's on the mechanical changes.
All right, I'm going to do Kurt just because it's a shorter walk. Oh, okay. Well, Simon.
Just a comment for whoever was tagged to fix the potential ESP issue. In our media layer, I found the simplest solution was to do a loop starting at 32, then 16, then 12, and stop as soon as NewFS, MS-DOS, or whatever it is, successfully creates the EFI. That way you get the largest fat thing that is supportable for the size that you're trying to build.
I will let Warner think about that.
Another comment from the NetBSD world as well. So looking for building packages from the ports tree without root privileges, and bootstrapping also ports in a user level directory without root permissions as well, like we do, like it's possible to do with package source. Just a thing. Thank you.
I may be wrong on this, so hit me with a clue bat if I am. But as far as your new way of wanting to run releases, I would have updated several machines at work to 15.0 betas and then RC if I could do it through FreeBSD update-upgrade. As far as I know,
you can.
Can I today go through?
Yes, FreeBSD update works and will continue to work for the extent of the 15.
No, I didn't think
release.
that. I didn't think it would. We had the images and everything that you could update.
Yes, all the betas and release candidates are there in FreeBSD update.
And then you can get to the real release once that's out.
Yeah, and then you will run FreeBSD update upgrade - our 15.0 release.
Oh, okay. Is that new with 15.0 or that's?
No, that's been there since,
I
don't know, 2005 or so.
Well, and I think the thing that I mentioned yesterday is originally the goal for 15.0 was we would only ship package. And we have, as part of calling it a technology preview, because it has been, I think, partly to Colin, like flag waving and a lot of work by folks like Ivy. We're a lot closer, I think, in 15.0 than in any prior release, but we're not quite there yet. So we're going to do, like, both paths will work. But that means that using FreeBSD update as you do today, as Colin said, should work for the whole branch.
Right, so just to clarify, in terms of upgrading systems, you've got a system running 14 right now. You will use FreeBSD update to get it from 14 to 15. At some point during the lifetime of 15, you will run package baseify. And then you'll have a 15 system running package base. And then you will use package base to update it to 16. Now, when I say you will use package base to update to 16, that may involve running a command called FreeBSD update, which says, oh, you're running package base, we will run the package commands for you. But you will run package baseify at some point during the lifetime of your system running FreeBSD 15. But you do not need to run it now. I do not recommend running package baseify on 14. Use FreeBSD update to get yourself to 15.
I had Ed's demo yesterday. It was Colin, by the way.
There's one more behind you.
So we had some interesting issues with partially built package sets last time during the I think you needed some small subset of stuff built and it nuked the rest of the package set. Have you given any thoughts of better ways of handling that moving forward so we don't end up with small subsets of packages being published and then people finding all their packages disappear temporarily?
I believe that the long-term solution is that package sets are going to go away and we're going to have package groups. I'm not sure exactly what that means. That's a Baptiste thing and he's not here. But I do recall there being issues and I believe those were fixed, for some definition of fixed.
Well, I may restate Adrian's question. There's a there's a difference between you build packages, but then you have the opportunity that we mostly don't use, that you could choose whether or not I'm going to publish the things I just built. I think with package base, it's a lot simpler. Your build world before, because we build world first, and then you build a set of packages from that. And if build world fails, you're probably not going to build a set of packages. So you should, in theory, either get a complete set of packages or you get no packages, as opposed to imports where somebody broke some dependency that breaks 5,000 packages and we build a truncated package set. So when you try to upgrade, then it wants to delete half your things because there's nothing there. Like there's no Firefox.
Right, because there have been issues with ports.
I think we want
removing things, yes.
There's no hits. Like this thing that broke 3 months ago in head was the subset of packages built did not include.
So, but that's. All right, yeah, I'll let Brooks try to say what I'm saying.
So I believe the issue here was that the way we're building packages is incredibly stupid for out of ports because we're building on underpowered hardware and it takes forever. And Colin needed a package set that would let him build a release at all. So he had them build the very minimal thing that had the things that are absolutely required. So I think we had one package set with like, a couple dozen packages.
We went from having a package set which would not install at all because it required versions of libraries that didn't exist in head anymore, to having a package set which would install but only had a very small handful of packages, which is what I needed to build the snapshot builds, which were needed for other things. And then a couple weeks later, we finally got actual complete working package sets. Yes.
But I think there's still a question of just because you build a package, do you publish the thing you built? And currently, we don't actually take an opinionated, we don't have any view of that. We just publish whatever the last thing we happen to build, whether it built or not. And this is different in base and ports. I think in base, we'll probably, because the way we build packages, because it's an output of build world, if build world fails, we have no packages to publish and we kind of choose to do a whole set or not. Now I think this is, no, but on ports, we have this problem with some regularity where something fails to build and we build a truncated set of packages and we don't currently make any decision about whether or not we'll publish. So that's one question, and that affects ports, which is not base. In base, we also have a decision point on things like reling branches when we're publishing a security advisory. Today, the way the build whatever built last night thing that runs on Baptiste machine works is when you push a patch to reling whatever that patches bin ls, we build all 300 packages again and bump all 300 packages version numbers because it has a date stamp, and when you package upgrade, you download all 300 packages and apply them when only ls changed.
And that will not be an issue in the reling branches.
Yeah, well, that's what's like. We should have some intelligence about deciding what we build and what we publish, and try to because part of the feature of the current FreeBSD update model is it optimizes for minimizing the amount of things you have to download and how much diff you have to apply. It would be a shame to lose all that, and I think part of that comes down to what packages we choose to publish. That it's a decision about choosing to publish a subset of what we build out of the base system instead of publishing the whole thing, even if we still use build world to build the whole thing. And that's a base thing. I think on ports, there's another opportunity to think about this, but we're talking about base, not ports for the time being.
And also, and this dovetails to the other dimension, which is, like, this is all great, this is release. But like, I hope no one's running release builds and then committing to head. I hope everyone's still running head and then committing to head. And I say that half facetiously because places that I've worked at, everyone runs a much older release that they then write code against, and then they try to push that into the mainline branch, and everything breaks. And the reason I bring this up is, like, this all looks good for release management and package base and ports for release branches, where there's a checkpoint in time where you all get to, like, hopefully decide everything's okay and pull the lever. But for people who are running head package base, are we expecting people tracking 16 right now to always build their own packages and build world? Or are we looking at having the opportunity to actually streamline our package base and our package set so that you don't have that sort of like activation energy required to build a whole base system and then build Chromium just to have a stable set of head packages?
If you're running head or running stable, you will be getting package-based packages from package.freebsd.org, the ones that Baptiste is currently building every night. Package-based.freebsd.org will only have the release bits, things that are built by the release engineer, signed using the release engineering keys. The stuff on package.freebsd.org is signed with the package keys, and it's the stuff that Baptiste has been running for years now.
So John was just talking about a bunch of issues that we fought long and hard with our PLMs about over packaging. I've mentioned before I don't like the way packages are built in base at the moment as a side effect of doing build world. I think they should be first-class objects in and of themselves. I wasn't going to do anything about that until the whole dust had settled and show a proof of concept of how you do it the way we do it. But I will comment that it's a good idea to think long and hard before you start releasing packages as to how you're going to version them. When you do a clean release build, it's natural that all the packages will come out with the release date or the build date or some indicator that they were all built at the same time. But it helps enormously if you want to be able to just update the ls package or you just want to update the libc package to allow for the concept of all the packages in my system have different, quote, versions, dates, whatever, similar to what you get with ports. We had a problem with our old legacy system where everybody was used to every build built all the packages and so on, and that made it very hard to move to a more componentized system. And the easiest way to break that cognitive dissonance was to say, no, when we build our packages out of our FreeBSD system and our various other components, we make no attempt to make the versions align because then you just cause confusion down the road. That's all for now.
Yeah, I think sometime around FreeBSD 17 or 18, install world might be going away, and we might have build packages and install, or build world packages, install world packages, because at that point we'll be using pkgbase anyway. But that is not happening in 15, and I'm pretty sure it's not happening in 16 either.
Yeah, we could eliminate the install if we just generated the meta file directly with the tags in it that say, get the file from over here rather than this tree over there.
That could be a useful optimization,
that would be much faster and more amenable to subsetting and change sets than we currently have. So that's something to keep in the back of your mind when we go to do all of this. As well. So there's a number of things we can do, but we haven't decided on what we will do, which historically suggests your statement about 17 is right. I was going to nitpick it, but I just realized that maybe I shouldn't.
Yeah, I was just going to emphasize the comment sort of circling around is once you transition to installing packages, then there was comments yesterday about needing to eliminate root privs for building stuff. When all your build is producing is packages, there's absolutely no reason for anything to run as root. All of the artifacts can be built as non-privileged users, and if you're only installing the packages, you can do that as root. So it's very easy to eliminate a lot of issues that we currently have.
Yeah. There are occasionally issues to do things as root. So in terms of the release engineering builds, we are currently using the non-root build code, but actually running it as root, because all of the builds for all the different architectures are run in different jails at the same time on the release builder. And so the release builder needs to create these ZFS systems, file systems, and then also mount a devfs inside them before it runs these non-root builds as root, just because it's already root. So being able to create jails is sometimes useful when building things. We don't do that as part of build world, but there are cases where it is necessary. or at least convenient. But yes, we are moving towards not using root as much as we can avoid it. Any more questions or comments? I think we're done then.
Thank you very much, Colin. All right, we have a break now for a bit. Let's see, I think for half an hour. So we'll be back here at 11:45.
Check, check.
Okay, folks, if you want to get back to our seats, we're going to start up in another minute or so. How many bad languages do you want me to fix? How many bad languages that I don't know? How many bad imitations do you want me to do? You know, I can do bad imitations as well as anybody else. That's fine. My bad imitations. What's this way? My styling microphone in a way that's not ideal for a photo. You have to warn us. All right, folks, I think we're about ready to get started. We want to make our way to our seats. I know lunchtime is coming. You just have to be patient, bear with us for a little while longer, and we will have lunch after this. I promise-ish. So our next session we're going to do for today is going to be a discussion panel. So we have no slides for a change. And I'm here on the stage with Brooks and Pawel and Michael, and we're going to be talking about maybe security adjacent or security-ish topics, but are things that are kind of either our experiences in industry or things that we know are kind of coming that we need to maybe be prepared for. So I'll let each of our panelists introduce themselves, and then we'll start off from there.
All right, I'm Brooks Davis. I work on the CHERI project. Been working, which brings memory safety to C and C++, among other things. And I've also been working lately with the European Telecommunications Standards Institute on a standard for memory safety, as well as attempting to interface a bit with the CRA standards there.
My name is Dawidek, or PJD in FreeBSD land. I work at Fudo Security, which I co-founded, and we work on privileged access management. In FreeBSD, I was working on a lot of different stuff like disencryption or geom, porting ZFS and stuff like that.
I'm Michael Windsor. I co-founded a project called Alpha Omega. We catalyze improvements in open source security by turning money into security, which is what the t-shirt says.
So Brooks, you mentioned memory safety standardization. What do you mean by memory safety? Do you want to kind of flesh that out a bit?
Well, that is the fundamental question here. Something that was observed in the UK program that funded a test chip and prototype from ARM called Morello, adding CHERI to their CPU, was that the government clearly wants memory safety in products, but they currently don't have a way to ask for it. There is no standardized language. If you asked for memory safety, who knows what you would get? You could pick a winner. You could say, I want Rust on this thing, or I want this to be written in some other memory safe language. But you can't express a general requirement in a way that's compelling and frankly legal. So there's an effort to define what memory safety might mean in sort of a tiered approach. We want to give some credit to people who are doing the right thing today, who are applying basic mitigations, which should be applied. But one thing that's been observed is that if you don't specifically ask for these mitigations today, you don't get them. Most Linux systems, for instance, run with executable stacks because glibc does, as an example. So we want to write down some standards and some language that allows both procurement officers and regulators to ask for memory safety in a in a standardized way. So that's an effort that's underway. We're hoping to have a draft standard mid next year, and that's part of a push by the UK government, and then it'll be a Europe-wide standard.
I have a question for you right away. Can I jump in? Can you give us an example of how you might specify some aspect of memory safety?
So we're
more than use Rust or don't exceed your bounds or something like that.
So we're looking at some sort of types of memory safety. So we talk about spatial safety, temporal safety. In CHERI world, we talk about referential memory safety, which is that your pointers are protected from manipulation and things like that. So we're trying to write a vocabulary essentially, and then I think the standard will probably include some sort of worked examples of this technology stack gives you this kind of protection, and the words apply in this way. So we might look at EMTE from Apple. We might look at CHERI. We might look at a system using Rust, and try to work some examples to help people fit their technology into the language.
And then Pawel, I believe, when I talked to you a bit before this, you talked about you have maybe some, I don't know if challenges is the right word, but you've learned things from experience of how your approach to using generative AI inside Fudo and what you're doing there.
Yeah, so we try to using agentic coding agents to see how we can increase our productivity, and I try to promote this within my company, but of course there are some concerns. Once you start generating a lot of code, it's basically almost impossible for this code to be reviewed by humans. It's clearly another bottleneck that people have to review the code. So of course you can try to again use LLMs to review the code, but it's hard to get rid of trust issues.
How do you trust the LLM to review the thing it generated and have any confidence whatsoever that's meaningful?
You've used the word trust and LLM in the same sentence.
That was on purpose, but yes.
Yeah, especially that I promote zero trust. So yeah, but so yes, that's maybe not the best or the only approach. And what I found is that because we invested heavily at the beginning of creating the product into Capsicum and sandboxing pretty much everything we could, and basically being able to define the boundaries of what this sandbox code can do. So this helps a lot to mitigate or eliminate those trust issues, because if I know that this generated code is running in the sandbox, I don't have to really spend too much time on reviewing the code or making sure this is secure, because I know the sandbox itself is secure. So for example, even now we have to leverage our product monitors different protocols. So we do leverage open source to monitor protocols. Like for example, for SSH we use OpenSSH. For remote desktop we use FreeRDP. For MSSQL we use FreeTDS. So we leverage a lot of open source projects. But what I don't want to do is to audit all the code. So what I want to do is to simply close the code in a tight sandbox and forget, right? So this is not part of TCB. And I think that this is what works nicely for us, and this might be interesting to see in the future, that there will be maybe trend in this direction to, if you use code generated by AI, maybe you should sandbox it so you don't have to try to make sure it's secure in different ways, right?
I think you should take the word maybe out of that sentence. You should. One of the patterns we see with AI all too often is treating it as if it was a privileged entity, allowing it to run code or generate code that runs in a privileged entity, right? And you wouldn't let your end users or your clients have raw access to your back-end systems. You have APIs which have policy checkpoints and all these things to try and enforce things like that. But then you spin up some AI agent to help you do customer service and give it total back-end access. What could possibly go wrong? And I think it's funny because I sort of connect the two topics in an interesting way, because you talk about type safety, you're talking about essentially component safety or a granularity of safety that's perhaps chunkier because of implementation limits, right? I think yesterday I mentioned I would love for languages and package systems, which are unfortunately all too decoupled, to have declarations of capabilities as part of the usage. So if I'm importing package foo, and package foo says I need file system access, I'm like, that checks out. And I granted file system access at the runtime level, type safety, whatever you want, right? Then subsequently, I'm not surprised if it accesses the file system, right? And if I want to constrain what file system it can have access to, I create a sandbox or CHERI or whatever I want. If subsequently someone updates the package to also start pulling from environment variables and do network access, I have questions, right? And I still need the code to run. Maybe it doesn't have a code path I don't want to use, so I want my language environment or the type safe environment, the sort of safe environment that things are running in, to enforce some of those boundaries. And what's really frustrating is now we're just wandering into the same nightmare of premature factorization when people build up microservices architectures who haven't written a line of code. I want the tools to do this for me. I want to write my code declaring boundaries of interesting things, whether it's memory or access or whatever, and then have the system decompose that for me and figure out what needs to run in what sandbox, what process boundaries need to play in, et cetera, et cetera. I think big in this one. So, yeah.
Well, this wasn't even on my topic list, but one of the things that I'm working along with Brooks, kind of our big project over in CHERI land at the moment, is we have, CHERI gives us a runtime environment where we have like spatial memory safety mostly works. You don't really have to think about it. And that gives you a foundation that you can, as Brooks mentioned, you can run in an environment where you have a constrained view of your address space that is smaller than what the MMU is. And you can have non-overlapping sets or kind of partially overlapping sets, but you can construct somewhat arbitrary sets of memory you can access.
And that's not constrained by things like processes or whatever.
No, and it's much more fine-grained,
Yep.
and it's much cheaper. And so the thing that we're now kind of pushing on is how small can we make the boxes, and how can we make the boxes smaller while kind of minimizing the pain and suffering that the developer has to go through. So like I'm working on changes in the static linker, so we're able to change the way the linker glues things together, so we can place different functions in different output sections and kind of have different functions isolated from each other. So even if you have a library that does file system access and it does some decoding of like an image over here where it has like 5 different codecs, we can put each codec in its own box, so that if you compromise one codec, you can only get to what's inside that codec's box, even inside a single library. Because one of the things that frustrates me about modern software, I'll try to be polite in my words, is I enjoy working on what I think is this bottomless layer of software, because there's nothing beneath me but hardware that it's just a black box, and that's part of life as a software person. But modern software is layers upon layers upon layers upon layers, and it's rare to find someone who understands all the layers beneath them in a stack. They know the layer they work on. If they're at the top, maybe they know a bit about the next layer down, and if you're somewhere in the middle, you maybe know about your next layer down. You probably have no real idea about the people who are using you too much. But you really, like this whole, when you're working at somebody that's actually building a product, they really want to think about the whole thing. That's very hard with all these layers. And one of the things that happens with these layers, like in something like KDE, you have software that evolves. And so you might pull in 8 different libraries that all process audio codecs. And it turns out you have 3 copies of an MP3 decoder when you're using one of them. Because this person used this one to decode this codec, and then they picked library B to decode some other codec, and no one's really thinking holistically about like minimizing our attack surface. And at least I think one of the benefits that may come of the approach we're trying to do is you may pull things into your address space, but since no one uses them, they're in like a dead box that's isolated off to the side, and at least they de facto end up not part of your attack surface.
So back in the 2000s, Microsoft had a variety of techniques for improving the performance of its binaries in various use cases. And this was something called Lego internally, or basic block. Sorry? More than it was basic block something. But basically what they would do is look at the codes generated and then rearrange things so that they'd run Windows instrumented or Office in an instrumented state, and then they would rearrange the code to optimize the most common paths to be in local pages, right? And it created a significant performance advantage for their applications, and then it gradually became available in the compilers as well. This is exactly the same sort of thing, right? You're just different goals, but at the end of the day, move the parts that are needed to be in the various places, start to create, intentional boundaries around them, start to align it to permissions associated with those boxes in some ways, right? We're still dealing with very coarse-grained tools. I want to loop back to what I was going to talk about, because when you talk about that web, that graph of things where there's 6 different versions of things coming in, right? Sometimes they're the same one but different versions of the same product. Sometimes they're different implementations of the same thing, all of the above, right? That deep, we're standing on the shoulders of giants. It's amazing, but they're running downhill and they're pretty drunk. And being on the top of that, right, creates tremendous difficulties. And we've seen data here that, I think I said this yesterday, every sort of package starts out with Dependabot pulling in updated dependencies on a regular basis, and they stick with that right up until something breaks the build. And then they repin it and move on, right? And it's pretty consistent. We can look at the data and see it, and we're like, well, that sucked, right? And that's bad at one level, right? But when you do that all the way down transitively through the closure of your dependency graph, right, it's unmovable, right? The number of humans and human interactions required to fix all those things, forget the actual changes to the code, just the number of human interactions scales up pretty badly. And it's interesting to think about this from a security perspective, because that is now a tar pit that is slowing down updates and picking up changes left, right, and center. And it's interesting to think about, well, why is it that way? Right? And this is now like when I was writing software, which is a long time ago, many of you were not yet writing software, we'll put it that way.
Kirk was.
Yeah, fair enough. we established credentials on that front yesterday. Card punch was used at some point during the conversation. Card punch, for those who don't remember, are these weird things we poked holes in things like voting to actually tell a computer to do something really trivial. So back when I was doing it, we lived in a space where the operating system was a very thick layer that did a lot of things, had a very high compatibility promise, and then there was a mountain of proprietary code to build the application that you're doing. And you wrote tests for the code that changed the most, which was your code, your group. You wrote a lot of tests, and so when Kirk screwed up something, we had tests to catch his failures, and more than my case, it was people writing tests to catch all of my failures, and so that wouldn't go off and break the build horribly and so forth, right? Well, now we live back to these running on the shoulders of giants. Where's all the change coming from? It's not you. You're the volume of change that your software project is creating. Anywhere you are in that graph, whether you're the topmost application or component, your change is insignificant compared to all the stuff beneath you or around you or downstream of you. And at Google, with the monorepo, this became a problem very, very quickly, right? And the contract is you write tests to validate your contract with your dependencies. And those tests allow those dependencies to push up changes that don't break you, or if they do break you, they see how they break you, can fix it. And the rule is change your pays. Now, what does this have to do with security? Well, there's a whole bunch of research called DORA, DevOps Research and Assessment, that has understood 4 key metrics that drive productivity for software teams. They're frequency of delivery, latency of delivery, how long it takes to go from PR or coding to actually end up in production. Frequency of outage, how often does that process fail and the build has to be recalled or patched or whatever, and then how long does it take to recover from that outage, right? Those 4 metrics, which are not easy to drive directly, they're sort of top of the pyramid of a whole bunch of changes, are incredibly predictive, not just correlated, but shown to be predictive of highly productive software teams. So now put that in the context of you've just had a vulnerability report. How long does it take you to get that patch, the fix, assuming you found the problem and fixed it, how long does it take you to get it out the door, right? And if you are in a space where you can't pick up all the updates to your thing, it's going to take you a long time. You have to figure out the test coverage. You have to figure these things. If you can't get changes out fast at all, then everybody downstream from you is now lagging behind, even if they could keep up. And so at the end of the day, it still staggers me that most organizations write tests for their own changes rather than the graph of things below them. And the whole point of tests is that we can go fast and break things with confidence because the tests are going to catch things. And we can go faster, we can fix things faster, we can keep up. And so that whole, going back to the Dependabot freezing, pinning on the wrong thing, you would do that because when the build breaks, it's sort of an opaque integration test somewhere something failed, and it's going to take you tons of time to figure it out. Whereas instead, you could have a test that says, this API behavior changed, you know exactly what's going on between your expectations and the reality, or if you don't, you now write a test to do so, and subsequently you can keep going and staying close to head with your dependencies. So it's a long monologue, if you will, a diatribe, but it's just, I wish we would, and I'm looking to use AI, in fact, to start generating dependency-free tests that look at the implicit contract and do that for us so we can start to test.
It's also important to be aware, which is not always obvious, that most of the time all the tests that come with some software or people are preparing basically are only functional tests. And if you have security holes, right, all the functions will work. If you skip the authentication, right,
yeah,
all the tests that authenticate the user will work fine, right? You specifically have to test for those.
I'm not even talking about security testing here. I'm just talking about testing as a way to make it so that security is not an exceptionally nightmarish experience when it happens to a slow release process, right? Like that, it's about unblocking engineering productivity so that a security release is not a special case that somehow bypasses the 3-month life cycle you have to do something. And you know, I'm looking at you, telecoms, where your release cycles is measured in quarters, not weeks or days.
I think related is an approach, and I think everyone does it, but when you have a security vulnerability and you have a patch that comes out, you take that patch, which was developed against some version, usually the main head of whatever software package has a problem, and maybe they've backported to their release versions for you, and that's great and wonderful, but they've basically just taken the patch. Probably they assume if the patch applies cleanly, they've done some light testing. Oh, we probably know the code is probably good enough. 99% of the time, that's true. But then, like as a downstream further down from that, oftentimes you're not on the absolute latest release. You might be on a prior release. Then you're taking this patch, it's been backported from main to like equivalent stable branch, and you're applying it to release, you know, X minus 3. And if it applies, you think that's great. And then it turns out, oh no, it applied to the wrong function because the code actually in release X minus 3 is different and no one catches that and it ships out the door by accident. That's your 1% nightmare that I pushed out the fix and actually I didn't fix the bug and I introduced a brand new bug.
Right.
That is it's a novel bug in that version of the software you've just patched does not exist anywhere in upstream. It is a brand new artifact that no one has ever tested or looked at except this vendor that's 3 layers down that's decided to push their version of this thing. And I don't know if people like think about the fact that you're creating basically a new private fork for your patch applied to something else.
These new private forks are the worst thing. And I'm looking at all of you vendors who are maintaining. We're not on main on FreeBSD. We've got our own set of changes and stuff like that. Well, you're maintaining a hard and poorly maintained fork. Not because your code isn't maintained, but because your ability to pull changes that come from the community are not well maintained.
I got the opposite feedback to that.
Okay, opposite feedback.
Let's get you a mic first. I don't know if I want you to have a mic, but it's probably better for everyone else if you have a mic.
So, I'm shipping 100 million devices, and there's a security vulnerability. I don't want to pull in everything from upstream to fix one security vulnerability because I have to upgrade 100 million devices, a percentage of which will fail due to random chance during an update, not due to anything that the diff did, right? So like, it's not just, like everything from the security theoretical standpoint, practicality standpoint, I agree. But I have 100 million devices to upgrade. The point releases are done because sometimes my vendors will say, and I'm talking about real vendors that are like within half a mile of this location, they'll give me a security fix with an entire 500,000 lines of code with it as their BSP fix for that particular security vulnerability, and I, as the actual person shipping a product, gets to make a choice. Do I spend the time and the risk of just fixing that one thing and hope that it's got it? Or because the vendor's given me 500,000 lines from all their upstreams, because of all the dependencies involved in just, say, the Linux kernel, do I upgrade all of that and maybe nothing will break, but that probably won't happen, but will it introduce other vulnerabilities too? So I have a practical problem to solve in delivering actual updates that sometimes forking that thing is the least risky thing to do.
I think the trick is making sure that you're aware of the trade-off you're making and understand the consequences. And because it can be a trade-off, but just being aware of the trade-off and not being and realizing the trade-off is not free.
Right.
And knowing what your costs are and what your obligations on yourself that you have de facto forked, and now you have this really private artifact. It's not really OpenSSL 3 point whatever. It's my SSL 3 point whatever.
Well,
just being aware that that's true.
One of the things I would like to see is tooling specifically to your scenario. I would like downstream forks that are making decisions to cherry pick things down to be operationalized, to be normal things that don't require Herculean effort to keep them going or weird things. And for you to have, again, back to my point, the test coverage at the unit test level of functionality to know what has changed across those 100,000, 500,000 lines of code and 27 different dependencies and so forth, so that you can start to make a more reasoned decision rather than a volume-based decision. Wow, that's a lot of code. I wonder if it's good or bad.
But again, in the shipping products world, like I may have a 48-hour window.
Right.
I may have a government-mandated window to push an update because I have got a legal requirement by the FTC, for example, or some other like government organization to put updates where the length of time it would take for all of that validation to run may actually go against other competing pressures that I have, right?
Yeah, that's a good one. Google 3 would enter the chat and tell you it's easy. Spend $3 billion a year on compute infrastructure to do it. It'd be great. I know they are. and that's a problem too, because they can keep up to date with their head and then ship things to you that are going to make your life very difficult. No doubt about it.
I think one lesson is software is a mess and hard, right? Like it is deceptively easy to manipulate software. It is much harder to reason about products.
But I think that security creates panic. Whether it's a government saying you must do it within 48 hours as opposed to you need to do it the right way, right? Or whether it's a telecom that is used to publishing things on a quarterly basis or annual basis, right? Sabre, for example, is basically treats every one of their clients as a totally unique version of the software, and their clients don't want to have updates more than once a year, right? So all of those things create interesting dysfunctions, but they also tend to throw all the things that we know about software engineering at least a little further away from the reservation here, right? And so that's like software engineering is a set of practices on top of programming that allow us to stay resilient in the face of change, in the face of externalities. The bridge does not fall down even when it's blowing windy or whatever things happen after we've learned what patterns cause it to happen. And at the end of the day, security is really just, it's just a bug, right? There was a bug in the code, it just happened to create an exploit. By the way, I really like what they're working on because the whole point is it's intrinsically, security will be broken, there will be gaps, there'll be holes. Let's put boundaries around these things in different ways to make sure that we're not, so that then when someone makes a decision to take a patch, they're not, creating more weaknesses for themselves.
Yeah, and especially as you said, that for example, you have security vulnerability and how much time you should spend to provide a fix, right? Maybe it's already exploited in the wild and you should be in a hurry. And I wonder, like, as a consumer, you can make any assumptions or expectations to how long will it take for this vendor to provide a fix, or if you have to mitigate this anyway. You have to have procedures to respond quicker. Like, for example, I don't know, how to respond to 0-day. Maybe have like redundant infrastructure that use totally different.
Or just turn it off.
Or just turn it off. Yeah, that's of
I mean,
course.
sometimes,
Yeah.
would you like to lose all of your customers' data to somebody, or have your customers not be able to buy stuff right now?
Yeah,
Most businesses make the rate trade-off right there, right? Oh, yeah.
So one issue that's come up a few times recently is staying up to date with your upstreams. But that isn't always going to work out well. I'm thinking software projects tend to grow over time. And I've seen a lot of cases where someone starts depending on a project which is maybe 10,000 lines of code. And then a few years later, it's 1 million lines of code, and it does all sorts of things it never used to do, and its attack surface is huge compared to what it used to be. So you don't want to import all this new garbage they added. You really want to stay with the old version that was small and a lot more secure.
So there's an old Rob Pike saying, a little copying is better than a little dependency. And that what the definition of little, or given value of little, is changing as we think about these things. And you have these 3 choices, 3 Fs. You can either fix things upstream, you can fork them, or you can forget about using this. And when your upstream dependency that started out as 10,000 lines and seemed reasonable has swelled to 1 million lines of code, you now have a problem. And the solution is not to, well, like, you're doing one of those 3 whether you like it or not, right? So you've effectively forked it, which is not going to go well, right? You should forget about it and toss it out and say, let's get the code that we want and own that it's now our problem, our code. Because it is your problem, it is your code. You're just maintaining it without admitting it, or occasionally picking up an update and hoping it's okay. But going back to the AI angle, I am hopeful about being able to extract code out of these things. And again, maybe even in an ongoing way. This is something that the Linux curl, Greg Cage and I have been talking about, which is if we can automate writing of tests, discovering through what we use, can we also automate writing, extracting the parts I want from your damn code and not the rest in a scalable way? Because you're right, I shouldn't be bringing all this stuff in. And he's right, we should have permission modules and boundaries on these things so that even if I do bring it all in, most of the stuff it wants to do is not able to be done, right?
But also it's interesting, as you, John, mentioned, that you sometimes bring one dependency because you need, for example, I will use FFmpeg as an example. You want to bring FFmpeg because
the only possible response.
because you want to have like one codec, right? As you mentioned, and but you bring all of them, right? And there was actually an interesting case where Polish security researchers started to do some fuzzing on FFmpeg, right? So of course there are codecs that are well tested, well maintained, right? But he found like over 100 vulnerabilities in some very exotic codecs running on PowerPC, in assembly or whatever. Some really stuff that nobody really uses, right? But the code is there, right? It's shipped, it's part of the package, and even though you need just a single codec, you bring all of this mess.
But I mean, to FFmpeg's credit, I believe they tell you you should do a custom build of this with only the parts that you want, but nobody does that. It's a pain in the ass.
Well, because you as an OS vendor, you want to ship an FFmpeg that anybody can use for any common task. So what do? You turn on almost all of them because you don't know some, random person in like Iowa wants to use this one, and then somebody else wants to use that one, and you're stuck because they'll yell at you if you don't include the codec they use.
I mean, this is how you got things like the zero-click vulnerability in iOS that was in the JBig decoder.
Right.
Because they stole it out of something else, and they were using it, and it's one of my favorite exploits.
I love it too because the only source of imagery was the app itself, because all apps into iMessages had to come through iMessages, or their SMS bridge, and so they could have happily recoded all those images to a format and had only one codec that was their codec, but no.
Well, and it's one of 2 cases recently where they got caught by a file rename bug, which is just super embarrassing. The first one, okay, fine, but the second one, yikes.
Sounds like we got a question.
I do. Since this...
he's reading his question from notes. This is not going to go
someone
well.
also should know what time I'm supposed to stop this.
In 15 minutes.
All right, okay.
So since this is the emerging security trends, the one of the most impactful ones on me hasn't been mentioned. PQC, we have a mandate, government mandate and now company mandate. Our products are supposed to be fully baked with post-quantum crypto by end of this year. We're not going to make it. I'm surprised there's no discussion from FreeBSD, general thoughts, or any other vendor facing the same
crypto,
mess.
So.
Yeah, I mean,
we ship crypto.
There actually is an article in the journal, the most recent one, of somebody who's using a library with Nginx, at least for, I think, the key negotiation. But there's only so many topics I can fit on a panel at once. David is part of it. Like I
guess
we can boil some parts of the ocean, but boiling all the ocean is normally out of scope.
None of us stayed in a Holiday Inn Express last night, and we are not going to actually voice any crypto knowledge whatsoever because.
Well, it's more of an algorithmic. It's
right.
not rewriting the crypto. It's.
But there is an interesting talk from I think DEF CON that you should start panicking. There's a lot of improvements in the algorithms, so basically we don't really have much time. So
that's kind of why I thought it would have come up.
I think that if you want to take, I think the most important thing you said there, in general with respect to security, whether it is memory safety in most of the code that's running on the planet today, and the kind of weird attacks that people are coming up with where it's sideband or side channeling to that, right? Permissions models and identity systems and all the messes like that, or supply chain security, you should start panicking. Because the scale of things is changing. I think this, we are now seeing increased sophistication on attacks that are just straight up against sort of the lack of memory safety in the language. Compile is just too easy now. But then even just in the hardware environment of side channel and branch protections like that, identity systems and like anything you can think about in terms of managing access, well, good luck. Is the person actually the person, or are they a sock puppet, or are they, proving identity? Oof, right? And then the supply chain space of like open source, everything using it, all the problems you talked about, all these different changes coming in, too many stuff, big packages, lots of different people, don't know who they are. We've made all these huge trust assumptions that just are not scaling well at all. And now AI is able to go off and do things at scale, such as participate in a working group to become a valid contributor, is something that an engineer could do on 2,700 projects with one AI to help them out. Man.
So to bring it back to like...
We don't want to talk about crypto.
No, I don't want to talk about crypto
okay,
either. Don't worry, because even I won't talk about crypto. What do we do? Like, over the last 15, 20 years in FreeBSD, there's always been pushes to like experiment with ways of improving base system security. FFmpeg's a great example, right? Because when you actually run this on Android, I don't know how many people have to deal with the Android ecosystem, but those things are supposed to be sandboxed with IPC on either end. They get run in a C group in a sandbox. If there's an exploit, there's very minimal footprint, right? And then the vendor comes along and speed runs in and says, oops, you need to run out a particular version for this particular hardware decode path, and everything becomes crap, right? But Android provides the sandbox infrastructure. It provides the IPC infrastructure for people to build on top of so that they can build components on top of the operating system without having to reinvent them. We kind of started doing that in different areas, right? Like we have Capsicum, but not a lot of stuff uses Capsicum. We have jails, but like our base system, our base stuff doesn't use jails by default for services. It's an option you can turn on, but we don't use it by default, right? Like the Armorello stuff's great. I don't have it. Like I don't have it in a shipping product still. So like where do you think we could take 16 and 17 and beyond on the commodity hardware we have, which I will point out, everyone deleted all the security stuff from 30 years ago because like multiple rings and like trap gates and all of that implemented all the security everyone wanted in mainframe world was too slow. So all of it's gone, right? For the most part, unless you want to live in hypervisor land. What can we do in the base system so we can give better tools to people and then consume it ourselves, so we don't end up with like 3 things using Capsicum and nothing using jails, right? Because we got to set a better example for the stuff that we write, and I want to be able to provide, like, I don't want to have to reinvent the wheel every time I build a service on top of FreeBSD to like, how do I speak like M-mapped, like lightweight FIFOs in and out of processes that I want to sandbox. I have to reinvent that every time. I don't want to reinvent that, right? How do we make those pieces available for people to build on top of?
I mean, to some extent, the traditional approach, for better or for worse, of how we evolve APIs and features and things in FreeBSD are people scratch the itches. So if you want an API that is a generic thing that handles IPC with mmap between sandboxes, you have an editor. It's not going. Someone has to.
Oh, that was.
I get it, but
it only took us 23 minutes to get to the passive-aggressive PR's welcome.
No, but he's right, and I've already talked to him about other stuff I want to do. But like, we as a project didn't capsicamize everything.
No, this is a FreeBSD problem I have no idea how to solve. That we are amazing at building the building blocks and terrible at actually using them.
Right.
Like, Pawel ported ZFS. And it took how long to get it into the installer in a kind of halfway usable way? Like forever.
But it was just CC install times. So.
Yeah.
Well, installer, yes.
So like, is this something as a project that we should adopt to push what we've got forward and be like, hey, everyone, let's do this in 16. Let's capsicamize everything.
So I think the biggest problem, like from my perspective, when I look at the big picture, is not that what we can do inside of FreeBSD. The problem is that stuff like sandboxing, capsicum is like a second-class citizen basically in software engineering, right? And even whatever tools we will provide, what guarantees do we have that upstreams will take on them, right? We have to work together with Linux, with other operating systems, that stuff like sandboxing or, I don't know, some kind of frameworks are actually standard and are basically required. So we have to, there must be a push and some kind of pressure on developers that, if you remember, long time ago, there was this shift that homegrown crypto is no longer kosher, right? If somebody will tell you that, oh, I created this encryption algorithm, it's super great, right?
Oh, okay, right.
He will be laughed at, right? So now we need to make similar pressure for people to like, so you ship your tool without sandboxing, that's so 2025.
I'm just talking about us. I'm not talking about all the rest of ports.
Well, so
I get it.
I think it's the same problem anyway. And you can do the peer pressure shame thing, and we'll give it about a decade and a half to make a difference-ish, right? If you can't figure out a way to make things secure by default so that your masses of developers, including the relatively small mass that is the FreeBSD community itself, doesn't have to do anything but gets those benefits, it's going to take decades. This has been true time and time again. And I actually think it's interesting to note that point, because FreeBSD as an operating system does not have the velocity or the adoption that Linux does, but it has certain advantages because it is a coherent set of things in a way that Linux distros cannot achieve, right? To think about what defaults can we make, right? And the progress around like the CHERI compiler work, authentication modules, maybe even starting to say, what if we double down on the hardware front and say, we're going to count on hardware that can help us enforce these things, right? And to start producing a truly golden path that has the kinds of things that you wish would be there all the time as default, even perhaps at the cost of performance, because I can tell you what, performance keeps coming along the ride. There's more compute still. Moore's law is dead, but somehow we find ways, right? But security is going to matter more and more and more and more and more and more. So take the hit, put it in a sandbox, have a compiler that puts things into sandboxes for you, whatever it is. And yeah, you should start dogfooding that in how you compile people's ports. Right? Because
but as
you
I
have
said,
all the code.
We need to dog food it internally, like even before ports.
Well,
how many things that we run as an example can you run in a jail today? And we had put like, this is a thing that popped up like in the last 6 months in FreeBSD.
Right.
People asked, I want to add stuff to the jail API because I want to run things in a jail. They need extra knobs for that particular use case. And then some people pushed back saying we don't want extra knobs to enable and disable features coming in and out of the jail because now jails aren't an actual jail. Where do we draw that line? Like we want to build these things that we can use internally.
So who decides today what the jail's API can and can't do?
What the right group of people awake in #Spark64. I'm not joking. Like there's a discussion that happens and then eventually someone lands the code or someone runs off and gets grumpy.
So how many people in this room feel that they would have a vested interest in changing how jails work to make them better for themselves and other people? Hands? Great, you have a working group. We'll see you after lunch. We're going to have the first meeting. Just do it.
Let's just, this is what I'm saying. Like, yes, I'm on the other end of that, where like...
No, you're the customer zero.
We consume all of this stuff from the Linux side vendors that they put on top of Linux to do all the things you've talked about. And it's like default Linux doesn't come with that. If I install Debian, I don't get any of that security stuff, right? So even non-FreeBSD vendors are facing the same problem. There's not really a FreeBSD problem, right? You have to run Android or a very specific set of things.
I don't think it's only a FreeBSD problem, but I think I think FreeBSD has a unique situation of an opportunity to address it in ways that the Linux space will take intrinsically much longer. Like I've been trying to work with the Debian folks for a long time to improve their get SIG store signing on their package things and like that. And I was told in a very friendly way that it's super easy to affect change at Debian. All you have to do is go to DebConf for 10 years in a row shouting about people, and then maybe something will happen.
Yes.
Right?
Yes.
So I wasn't joking. Those of you who raised your hands, you should be having lunch together and talking about this. And I'm gonna be very direct and probably piss off a bunch of people. I get to observe a lot of different ecosystems in open source, right? You can be better. You can collaborate towards things and have a clear sense of purpose and share things, as opposed to meeting in a space but doing things in your own space, right? You meet here, you talk about things, and then a lot of you go back and do things in your downstream fork or whatever. And I'm being hyperbolic and perhaps unkind, but this problem you just identified is something that a working group is screaming to exist for and should have vendor support and everybody, because everybody will win by doing it. And I think that the opportunity for FreeBSD as a community is right there because of the coherence of the system as a whole compared to the distro chaos that everybody else lives in.
And it's actually 12:30, so that is a note we will have to end on, for better or for worse. I think it's a fine note. But it is lunchtime, so we will now take a break, and we'll be back, I think, in an hour. Yes, I think we have an hour for lunch. So we'll be back at 1:30. Thank you all.
Thank you.
Thank you, panel. Hey folks, we're going to get started here in a couple of minutes if you want to make your way back to your seats.
All right. Okay.
All right, folks, I hope we've had a good lunch. We're getting ready to start back up, but I wanted to give a couple of announcements. So the last slot of today, we're going to do lightning talks. And I have had folks approach me about lightning talks. Maybe some of you didn't realize that people approached me on your behalf, but I have a list. If you look on the wiki page hung off the Dev Summit wiki page, I have a list of folks roughly in order that will go, and it's going to be about 10 minutes per person. If you are a lightning talk person and you want to do slides, why don't we do this? Send me an email with whatever slides you're going to use, perhaps ideally as a PDF or something like that, and I can have them staged on my laptop so that we can avoid shuffling HDMI and do it that way. And I'm going to be the last one anyway, so that'll work out. If you're not sure if you're doing a lightning talk, maybe I'll come remind you during the next break if you're not aware that you're on the schedule, and we'll go from there. With that out of the way, our talk after lunch is going to be Brooks, with perhaps a little bit of assist from myself, talking about FreeBSD and CHERI.
All right.
Go for it, Brooks.
Okay, so I'm going to talk about our efforts to bring CHERI to FreeBSD in FreeBSD 16. So for a few of you at least, you can probably wonder what the heck is CHERI. So CHERI is a processor architectural protection model that composes a capability system model with hardware and software by adding new primitives to instruction set architectures. The point of all this is to enable new security behavior in software, and specifically to mitigate vulnerabilities in C and C++ trusted computing bases, although it's broader than that. This is things like hypervisors, runtimes, language runtimes, operating systems, browsers, all the big nasty code we know and love. And it provides fine-grained memory protection, primarily provides spatial safety at byte granularity, and deterministically closes a wide range of vulnerabilities that currently allow arbitrary code execution, and also impedes a lot of classic exploit chain techniques. Makes it extremely hard to exploit systems even if there is a bug present in one of the TCPs. On top of that fine-grained memory protection, we can build scalable software compartmentalization. I'll show you a demo here of software running with hundreds of compartments, and we can run with thousands in some cases. This is at least an order of magnitude more than is practical with current software where there's any kind of performance concerns. And it's worth noting that this isn't just a research project, which is why we're bringing it to FreeBSD. There are now multiple industrial implementations, a prototype from ARM, designs from Microsoft that are being built by them and others, as well as designs from Codicip and Capabilities Limited. So how does this all work? Well, CHERI creates a new hardware type, the capability. CHERI capabilities extend integer virtual addresses, or integer addresses, and add bounds and permissions, as well as some other metadata, such as the ability to seal a capability, rendering it unmanipulatable and unusable until it's unsealed. We protect that metadata and the capability as a whole
with a tag. So on a 64-bit system, we extend the virtual address space with another 64 bits of inline metadata, as well as one out-of-band tag for 129 bits. We once upon a time had 257 bits. That was obviously untenable in the market. Although you could imagine scenarios where that would be interesting. It's never going to appear in a mainline CPU unless we start seeing 128-bit address spaces. That being said, the tag ensures that both invalid access to the capability, such as direct manipulation of the bits in memory by, say, accessing things by byte or word, as well as invalid manipulations in registers. So trying to expand the bounds of a capability, trying to increase its permissions. Those are all forbidden. When the tag is cleared, you can no longer use the capability to access memory. And in a CHERI system, all memory is accessed via a capability, either explicitly through new instructions or a new instruction mode, or implicitly via a default data capability and a program counter capability. That latter bit allows us to run legacy software unmodified. So CHERI enforces a number of protection semantics for pointers, in particular integrity and provenance validity. Ensures that you can't derive a capability, you can't derive one capability from another that can access something the original could not. It also ensures that all transformations must be valid and there's no possibility of manipulation. This is something that we've actually proven about the Morello architecture in a formal model. Bounds prevent access from being manipulated to access the wrong object. If you have a pointer to a string, you can't access some other random thing. Monotonicity ensures that you can't escalate privilege, broaden bounds, etc. And permissions allow you to limit unintended uses. So for example, you can implement write XOR execute permission at the pointer level rather than at page granularity. And these primitives let us both implement strong spatial and temporal memory safety, but also allow us to implement scalable software compartmentalization. So how do we implement memory spatial safety in C and C++? With CHERI, we have these capabilities. We replace all the pointers with CHERI capabilities. This takes up a bit more space and adds some alignment constraints to the code, but otherwise, they're just like any other type, any other hardware type. And then software TCBs restrict the capabilities. So for instance, malloc gets big capabilities from mmap, cuts them up and gives you small pieces. Likewise, the runtime linker, runtime loader, as John likes to say, takes mmap capabilities, produces sealed function pointers that can be used to access the appropriate symbols, but not jump to arbitrary regions in a library. And then hardware enforces these bounds continually. In addition to these explicit pointers, we have implicit pointers within our runtime. So, the most obvious thing would be the return address that's spilled to the stack in every function. That's now a sealed capability. So you can only return via a valid capability. If you manage to write over it due to a compiler bug or something, you just smash it, at least if you're doing, say, string writes. And then, so we replace those, we replace the pointers in the global offset table. In pretty much anywhere else there would be a pointer. It now becomes a CHERI capability. It's useful to think about capabilities as having a reachable set. So you have in your thread context, you have a register file, you have a bunch of registers with some of them which have data in them, some of which have capabilities in them. The part of the address space that you can reach is the transitive closure of the values in your register set and then what they can reach, and et cetera, et cetera. That's not necessarily your whole address space. In fact, it's definitely not your whole address space. And more importantly, you can have multiple threads of execution with completely disjoint sets of capabilities. This allows you to implement compartmentalization. You need a mechanism to transition between those threads of execution, whether that's in sort of a classic operating system-driven threading model or via some non-monotonic domain transition mechanism. I'm not going to go into the domain transition mechanism in any detail here, but here's kind of a picture. You take the picture we had before, now you can see two compartments. They can reach some things via their global offset table. They can reach some code. They have their own stacks, et cetera. And then there's selectively shared resources as well. One beautiful thing about the capability model with CHERI is that sharing is really cheap and natural. If you make a basically if you pass an argument, that's all you do. You pass a capability along, things can access the code you called, can access what you gave it, and nothing else. So I mentioned this before, but it's a good point to hammer home here. With CHERI, we have a transition path. There have been lots of capability systems in the past. Most of the hardware capability systems failed, some of them quite spectacularly. Intel is very shy of capability systems for a reason. I bet the company nearly lost at least once. Nonetheless, we've avoided these problems in many ways because we can run legacy code. So you can take a CHERI, you could take an ARM Morello system, and you can run an unmodified FreeBSD or Debian or whatever you want on it. You get no benefit, but you can do it. The next step along that process is with CHERI BSD is we can run a mostly pure capability environment where almost all of our software is protected, and then we can have some software that we haven't ported yet. For instance, a legacy web browser where maybe your port isn't stable yet, you still need to be able to access the internet, or a JVM or something like that. Ironically, actually, we show these two examples here in this picture of Chromium and a JVM, and we actually, both of those are well along in the porting process. So these are solvable problems, and we are solving them. Whoops. So CHERI has been demonstrated at a wide range of scales. We did our initial research on FPGA as a MIPS prototype. Based on MIPS, we've ported to RISC-V, Morello, and x86. Or, sorry, Morello, I should say, ARM application cores. ARM also has done a design based on their M-series processors, their M-series ISAs. So we can run everywhere from ARM Morello, which is based on the Neoverse N1 design, which is probably approximately Graviton version 1 at AWS, all the way down to a Microsoft design called Chariot, which is the smallest RISC-V form factor in 32 bits. It's got a reduced register file of 16 registers, tiny little 3-stage pipeline, and that works too. And in fact, the small size allows a bunch of clever things to be done. This is actually probably the first product that will make it to market. SCI Semiconductor expects to have chips back in the next week or two, and then in production early next year. It's a small MMU-less system, so it's not going to run FreeBSD, but everything up higher on this list can. I was hoping to demo Chromium to you today, and I have run it on this box before, but something has gotten horribly cross-threaded, and it is not running today, but I will talk about it nonetheless because it's super cool. We've had a team of 2 people working not quite full-time for about a year, putting in about 18 months of effort to port Chromium, which is arguably the grand challenge of open source C and C++. Chromium itself, at least the 2024 version that we forked to work on, is 27 million lines of code. It pulls in another 47 million lines of dependencies, over 700 libraries, many of which change all the time. And in fact, we like to give a demo where we change, we change, say, the libping implementation out from under it, basically, reinstall it, restart the application, different compartmentalization strategy. And then the V8 WebAssembly and JavaScript runtime, another 1 million lines of code. And then from a security evaluation perspective, it's beautiful because there's a critical memory safety vulnerability leading to remote code execution about every 2 days. So if you wonder why you always have to restart your Chrome web browser, that's why. It's a huge and complex machine with incredible performance demands, and things go wrong. So we have it when it's working to the point of being able to browse a number of websites. Some days the Google front page will load. Some days they're doing crazy WASM things in the doodle when it doesn't load. But many things work, and we have some nice demos there. It's worth noting that these two people suffered immensely porting this software. Neither of them was an expert in CHERI when they started the process. They were expert developers, but not CHERI experts. And they ported this software in a year and a half of engineering time. Compare that to the 100-person team that does security on Chromium at Google. So it's a fraction of the time, and we defeat some fairly serious issues. So this is the demo we like to show first. Many a security officer will look at this, or corporate security person will look at this CVE. They'll just see the number and they'll blanch, because this was a bad day at both Apple and at Google when they found it months or even a year apart for the same bug. Both of them zero-click vulnerabilities that were used to attack US persons. So this was a naturally occurring bug. Google did all the right things. They did fuzzing. They did all the usual CI things. They had code reviews, all the good stuff. And there was a simple memory safety vulnerability deep in the Huffman coding state that the fuzzers didn't find. So the bug was around for years, undiscovered by open source tools or any of the tooling they could find. Other bug discovery techniques eventually found it, though, and made for a bad day. So in our case, we block this bug with CHERI. The demo is a super boring security demo, which is like you click on the exploit, and the browser says, "Yep, I crashed." The renderer crashed. The difference, and the only difference between that and the non-CHERI version, is in the non-CHERI version, the undefined behavior happens. And if you had fully canned it, you could pop a shell or something. But we haven't done the full exploit chain. The thing is, we didn't touch the WebP library at all. We made no changes to it to port it. All we did is recompile it. And we blocked this, and we block a number of other vulnerabilities, both in other libraries and in the V8 runtime. So I'll make a brief mention of sort of the most recent thing you can get to run CHERI on, which is a FPGA platform from Codicip. They have IP available today for licensing. It'll be a RISC-V based on the upcoming RISC-V standard. By the time you tape out, it'll be the right thing. So Ruslan got all the bits and pieces up and running. We now have the NVMe working on the device, and I think most of the features done. I'd like to do a little more validation, but we're in pretty good shape. If you find you want to play with it and have a ton of money, this is an option. It's an expensive FPGA and a fairly substantial support cost. But nonetheless, it's real, and it's a design that you can license today to tape out. So if you want to learn more about CHERI, you can go to chericpu.org. Probably the best place to start for an overview is our article in the IEEE Security and Privacy magazine last year, which recently won a Best Paper award for the magazine. We also have an introduction to CHERI, which is getting a little old. Likewise, the C++ Programmer's Guide. I would suggest the online version rather than the PDF version, as it's a rapidly evolving thing, and we haven't issued a new PDF in quite some time. There's also the ISA specification, if that's your sort of thing. You could read ours, which talks about our version of the ISA. The RISC-V also has the pre-standard version online on GitHub. So you can read the nearly standard version. Soon we should even have instruction mnemonics, I think, finalized. So we're going to do a quick demo here. Let's bring that one up. And so I'm in the demos directory. Let's go do the uname, John. We found it works better if I talk and John types rather than me trying to do both and doing it both badly. So here we have a uname of the system. It's very noisy and the wrapping's slightly unfortunate, so let's fix that. Anyway, so we have a generic kernel running in pure capability mode, which is to say all pointers are capabilities. We also, this is true of the kernel, and now let's go ahead and do a procstat-a. So here we have some kernel processes at the top, which we can ignore. If you'll notice the emul column here with FreeBSD ELF64C, these are processes that are pure capability processes. And in fact, on the current system, every process that's running is pure capability. So fully spatially memory safe and has temporal safety enabled for the most part. Let's do a procstat-a CHERI. So scroll past all the boring kernel stuff. And then, so the P means it's a pure capability process. It's a bit redundant. The yes means that we have enabled revocation, which enables our temporal safety system. And then the number is the number of compartments running in the process. So fairly large number of compartments, pretty much inconceivable with process-based compartmentalization technology if you care about things like performance. Let's go ahead and let's do procstat compartments on Ocular. Yeah, that one should be good. So here, in our compartmentalization model, by default, we put every library in its own compartment. This is automatic, and unless they are doing no work, quite cheap. We also have the ability, as John mentioned in our panel, to provide a policy to a library linkage to place portions of the library into their own compartments. Effectively, the library becomes a series of libraries within one, but by keeping the same library name and basically not modifying the build system at all, except to pass additional flags in a few cases, and to pass a policy and possibly, in some cases, pass -f function sections, we minimize the impact on the overall developer. And in fact, you don't even have to think about it. So you link against libc, whether it's compartmentalized or not, doesn't matter. And in fact, we can change that out from under you, and you'll never know, except possibly performance if we do something really wrong. So here we have a series of things. We've got standard I/O. We have string library. We have a trusted string components. This is things like memcopy, strcomp, et cetera, which have no side effects and no storage, therefore are safe to call without trampolines. So we can do that. We've also put the allocator, which has strong capabilities that can, to covering multiple malloc allocations. We've placed those in sandboxes so that those are unreachable from the rest of the system. Provides pretty strong guarantees, even if you obtain arbitrary code execution in other parts of libc. Let's keep going a little. Yeah, so we've also done a similar thing with libc, but it's zipped by, that's fine. Let's go. It's up a bit, I think. I saw it. There it is. Or no. Yeah, there it is, yeah. So there, yeah, we basically, there's a common pattern in compression and decompression and image processing and stuff that there's some utility I/O bits, and then there's the processing. Sometimes there's more intermingling than ideal, but often it's pretty easy to split them apart. And so you can have, so if there was something wrong in the encoding or decoding component, it wouldn't have access to perform arbitrary I/O on the system. So let's see, let's let's go ahead and I guess one thing that's worth pointing out here is you'll see these Ds starting to appear. All the things that have a D next to the number in the middle, that's an indication that it was DL opened either directly or indirectly. So this is stuff that the person compiling the code didn't even know was there and didn't interact with at all at the time it happened. Probably they had obviously there's some way that it was registered to be loaded, but they don't know about most of these things. So this is just one of the complexities and one of the things we help get a handle on. Let's go ahead and run it under GDB, I think. D is explicitly DL opened, and little d is implicitly opened because you explicitly loaded something. So the author knew about the ones with the big D probably, but maybe not about the ones with the little d, because that could just change as a software engineering decision by the downstream. Let's see, you want to go ahead? Yeah, let's go R break on PNG. And then let's see if I can make it. Oh, yeah, sorry. Slightly ahead of you. There we go. Now we have a break. So let's go ahead and do a backtrace here. Let's see, and can we find an interesting one? Here we go. So if we see number 8 here, you see in the debugger, we're showing each compartment, each cross-compartment call, where we have a trampoline to go from one library to another. If you're familiar with compartmentalized programming with something like Capsicum or any other process-based technology, this will not look familiar at all, because your program is normally spread out all over the place in multiple processes, and there's no call stack at all. In our model, there is a simple call stack. You can unwind it. You can examine any frame in any compartment. It's all nicely in one place and easy to use. So let's go ahead and quit. I want to check our time here. Okay. I think that I would like to go ahead and present the rest of my slides, and then we'll pop back to the demo if we have time, or if people have questions. Because I ran way over last time. So, having demonstrated that, we have a bunch of things. I guess the thing we didn't demonstrate is explicitly how, if a buffer overflow, you'll get an exception in the, if you're in the debugger, and you'll be able to examine the capabilities, see why that happens. So we're planning to upstream CHERI support to FreeBSD. We think the hardware situation is in the right place, and we've got products coming to market over the next couple of years. So it's time to get things ready for FreeBSD 16. So to make that happen, we're going to upstream it over time. So why are we doing it? Well, first, in one case, FreeBSD, I think, needs a memory safety story. Actually, every operating system needs a memory safety story. Right now, pretty much all OSs, except maybe a few, some things from Oxide, don't have one. SEL4, I guess, has one in a sense, and they've proven a lack of undefined behavior. But large operating systems, there is no story. There is a story, it's not a good one. Well, the story is we're unsafe. I mean, or perhaps, some people are also telling themselves lies that they're going to rewrite their billion lines of C++ in Rust.
That's what AI is for, according to some people.
Well, there is that. We'll see how that goes. A clean translation will preserve the bugs, so that'll be exciting. In any case, in many cases, it's simply not practical to rewrite it. I don't think there's any real hope there. I think people are very optimistic if they think there's a hope. It probably won't remain acceptable forever. I think it'll be it's a long process. But I think, there are things in the regulatory space that are going to accelerate this. And if we don't want to be left behind, we should have an answer that's better than prayer. So we can reduce. So that's sort of the technical motivation. The other part of it is by upstreaming to FreeBSD, we reduce the risk for adopters, because adopters adopting some random research fork of the operating system, that's scary. I wouldn't do it. I'm glad I don't ship a product, even though we sort of do ship a product. I'm glad not to. And so if you want to iterate CHERI into your product and have memory safety, I think you'll be much happier getting it from a mainline thing. We don't want to be living in a world of board support package with a million lines of diff to it or whatever. We don't want to live there. We also want to provide a production OS with proven features versus every feature that's still in CHERI-BSD, some of which were good ideas and some of which were okay ideas, some of which need some work, and other which were not good ideas. So we
have literal PhD-ware, so we'd like to have
so
as
it's
much
definitely,
of that FreeBSD.
Quality varies. And the other thing is, by bringing in CHERI and being clearer about how we use pointers, because you have to use them correctly or things go boom, as well as being more expressively clear, as well as we do find latent bugs, will improve the quality of FreeBSD overall. CHERI wasn't designed as a bug finding tool, but it turns out to be a pretty good one in practice. And many companies who have done pilot projects have put Morello boxes into their CI environment because it found bugs for them, that many of which were long-standing and serious. And then from a BSD perspective, CHERI-BSD gives us a lead on CHERI adoption. We should have, I believe we will have spatial memory safety and temporal memory safety, as well as at least some of the compartmentalization work in FreeBSD 16. I think Linux will take considerably longer for both technical and political reasons. There definitely is a CHERI Linux. It doesn't have all the features that we have in FreeBSD by far. Many of the features are currently CHERI-BSD exclusives. And they'll catch up, but we're ahead. So let's keep the lead. So what do we plan to upstream? Well, RISC-V hardware, RISC-V is being standardized, and hardware is on the way. So we plan to upstream CHERI RISC-V. That sort of, I think, meets the sort of traditional criteria of FreeBSD. It'd be nice if we could buy boards today, but we're getting close. We're aiming for Tier 2 status over the longer term. We're also planning to bring ARM Morello. Now, ARM Morello is a prototype. It's adding CHERI to ARM v8.2. It was intended as a prototype. It has some architectural deficiencies, fairly small ones. It will not continue as a product. So the new thing, if ARM does a production version, almost everything will be the same. We'll get to remove some workarounds, but instruction mnemonics are the instruction mnemonics that will be used in almost every case. Almost nothing is expected to change. But right now, it's a performance system. Not amazing. It's only a 4-core machine, but it is a reasonably performant system. You can run a compiler on it. You can do demos, as we did today. So we're going to bring that in as Tier 3. Both that gives us carte blanche to delete it if it turns out that it's dead, and also it gives us the ability to break it if and when ARM decides they're going to ship a new ISA. We'll be able to follow right along. So we're not going to make a lot of promises there in terms of long-term support. But right now, I think it benefits the community to have hardware we can get access to. We're going to focus on peer capability programming. While I've mostly talked about that, we have an alternate programming model where you annotate some pointers as being capabilities. It's attractive in some ways in terms of porting software as a way to get started, but it's a trap. It ends up being extremely disruptive to the code base while giving very little security benefit. So while we have a hybrid kernel and hybrid user space support in CHERI BSD, I don't plan to upstream any of that. And then we will start with the kernel and then go to user space. The goal there is that we're going to have a pure capability kernel capable of running a standard FreeBSD, stock FreeBSD user space, as well as a CHERI BSD user space by end of March, roughly. And then we'll move on to adding user space support. We've already landed, I think, one set of patches so far. We've updated the Arch 7 man page with CHERI, and we're going to start adding types and things. Right now, I'm working through a process of removing hybrid support at a private branch to get my diff down so it's easier to extract bits. It's some manual work, but it's not too bad. So overall patch timeline, yeah. Pure capability kernel support probably by the end of March. We may not have landed everything, but we want to have a full patch set that's working. And then next year, by the roughly end of September, we aim to have pure capability user support. This is mostly changes to libc and the runtime linker, and then a few adjustments here and there for various things that aren't quite right in the pointer department. And there's like one case left in OpenSSL where they use XOR of pointers and things like that. Following that, we're going to work on linker-based compartmentalization, bringing that in, being able to provide protection to malloc, for instance, and protecting strong capability roots. And then finally, we're going to do heap temporal safety. Heap temporal safety is a bit more disruptive to the VM system. It's a larger sweeping change, so we're putting it out at the end. We also have some improvements we need to make to the overall malloc implementation before we can do that. I would say I'm highly confident about the spatial safety making it in, pretty confident about linker-based compartmentalization, and I'm not sure how long it's going to take us to refine the temporal safety work. We're also going to have to make sure we do lots of testing that we're not causing performance regressions there. So we'll definitely be putting out calls for testing as we get closer for people who have critical workloads. And then just a few words on our Git strategy, since you might want to follow along. We have a fork of the FreeBSD source repo on the CHERI Alliance GitHub. We're going to maintain rebased branches there with candidate patches once we get to that point. And also just upstream things through the normal process as we go. I've started tagging things with, I think, effort CHERI upstreaming. It was hard to find a Git trailer name that Fabricator didn't want to abuse. So I tried task, I tried project, and it got all cranky. So effort is what we've got. So I'm happy to take questions. We have 5 minutes, it looks like.
Can you just go back to that timeline page?
Mm-hmm.
So how firm are those timelines? Like, is this you're aiming for it and it may slip a few months, or you really think you could get all those done within those windows?
I'm fairly committed to getting the patches produced on this timeline, because I don't get paid if I don't meet the timeline, or I don't get paid in a timely manner. Merging them will take however long it takes.
Okay. I'm looking at that last one, the heap temporal safety. In July 27 is really when we're going into slush for 16.0 release.
Yeah.
I am somewhat skeptical, especially since this is fairly deep VM stuff, about whether we want that coming in right before 16.0 release, especially if anything slips in terms of timelines for getting stuff into the tree.
Fair enough. I guess we should try to be early.
Yeah, well, we'll see how it goes, but I just wanted to say that's the rest of it I have no concerns about, but that one we'll see if it gets into 16.0. If not, there's 17.0.
Yep. That's good feedback.
The first RISC-V boards you said are coming? On another page.
Yeah.
Do you have any thoughts or ideas what the board will cost an individual?
It is hard to say. We don't have a concrete plan for, well, we don't have concrete funding for a tape out at this point. We have two possibilities. We've been searching for funding. One option is to do something sort of Raspberry Pi shaped and hopefully priced based on the Codesip IP. The other is something much more vague at this point, based on a CVA6, which is an open source design from ETH Zurich that we've added CHERI to at Capabilities Limited. And that, I don't know what shape that's going to be.
Then can you go back to your tier slide?
Yeah.
Okay, but you said hardware is on the way.
Hardware is on the way. Hardware we can buy is a little less clear. There's at least one tape out that is, I think there's at least two tape outs that have happened in nearly, well, I think one is an MMU-less design kind of at the level of the Codesip board or IP. And then there's one that I know even less about from a company called CHERI, who I think is building it. I think they're targeting BSPs, so a high security BSP. The first sort of large scale product shipments are almost certainly going to be in secure enclaves. But we're trying to get something that's we can get into people's hands. It's just tape outs cost a lot of money and tend to be in the larger than someone with a large discretionary budget. You know, 10 million, you can find 10 million in the sofa, but 30 million is a little harder. So we're getting there. More Colin.
So in terms of having something that can get into people's hands, I saw that Deep Computing did this RISC-V board that fits into framework laptops. Have you talked to them about doing anything like that? I mean, that would get into a lot of hands.
We have not. I don't know. I don't know if anyone's got a CPU design ready to go on that.
I just mentioned, I know that they are enthusiastic about RISC-V, and they might say this is really exciting.
Yeah. Anyone else? All right. Thank you.
Thank you, Brooks. All right, so we have a break until 2:45, and then after that, we'll do our lightning talks for our last session of the day. Okay, folks, if we can make our way to our seats so we can do our lightning talks. I have slides for the talks, well, most of the talks. They're in order, so this should work okay. If you're not sure of the order, it's on the wiki, but also I'll just call you out if you're not ready yet. Let me go get my phone. So as a reminder, we're going to aim for 10 minutes a talk. So if my buzzer goes off, then try to finish or I'll come, so I don't have to come yank you off the stage. That would really help us. We do need to finish on time because folks got to get home. We got to pack the gear up and so forth. So do try to stay to that 10-minute limit. So to start with, Maxim is going to talk about QEMU and some interesting tricks he's playing with kind of doing Linux Accelerator in reverse.
Yeah. Hey guys, thanks. How do I switch the slides? John? How do I switch the slides? Just show me. Okay.
Or arrow keys if that doesn't work.
Okay, let me see. Oh yeah, okay. Yeah, that's good. Like a brief introduction of myself. So I found FreeBSD when I was university. Started using it like starting with 2.2 something version. And it was not, port collection was not that big back then, so I started by, like many of you probably, like porting stuff, fixing stuff, opening PRs. Eventually I got my commit bit around year 2000, so I started working on more ports, and at a higher point, I think I had around 350 ports that I maintained. I also helped develop some of the features for the, back then it was pkg_utils. Anyway, moved to Canada 2005. I'm pretty much self-employed and have my own business since 2006. We build software for phone companies, phone industry anyway. And we also release and build some of the open source components, again, since I like open source, and we try to contribute to FreeBSD as well. Everything runs on FreeBSD at our shop. Anyway, so going back to the presentation, topic of my presentation. So QEMU user mode works like this. So basically you have the binary that you want to run. It could be, for example, you have binary built for AMD 64 and you have ARM system and you want to run that binary. One way to do it is through the user mode emulation. Here is a QEMU, basically just loads that binary, interprets it, and traps any syscalls, and then translates them and relays between host kernel and the target emulated binary, interpreted binary. Werner here done quite good work porting it this to run FreeBSD on FreeBSD. And in general, this used quite a lot these days, especially when doing like cross-platform builds. It simplifies, you can dramatically simplify things because you can build 7 architectures in parallel without really thinking about cross-compiling and all this stuff. We build a number of components for like 7 or 8 architectures, some of which are very kind of strange, like IBM S390, which I probably would never have access to the real one. But anyway, so I digress. So basically the idea was to extend this to allow not only run like FreeBSD binary built for different architecture, but also do reverse emulation, like to run FreeBSD binary on Linux, essentially. So essentially, I took the port that Werner created of QEMU and extended it. So now it can run FreeBSD binary and modify it essentially on a Linux system. So you basically can take stock Ubuntu, download FreeBSD binaries, libraries, I mean, runtime, and run whatever commands you need. So yeah, basically I started with a pretty simple program like this. So basically simple hello world without any of the stuff. Got it working pretty quickly, kind of build it up a little bit, up and up. Eventually I got it to run whole trading library. And at some point the goal was to get the full build world working under this emulation, which eventually happened. So stuff that works right now, you can have enough. You have enough support to make build world. PKG mostly works. I had to patch libc. I still have that PR. Need to push it through. Basically, essentially, the problem there is the resolver uses some kind of weird routing socket, which I don't have implemented to figure out if it has IPv6, which I think a little bit how you doing, because why it uses such a complicated mechanism, I don't know. In any case, I probably will relax it a little bit. I still want somebody to review that pull request. So if you have some time, please take a look. Yeah, stuff works, signals, terminals, all the stuff. I can run bash. I can do like pkg install with that little caveat. And also managed to merge the latest QEMU10, which I plan to push pretty soon. Also, I did not include it here, but I also have full CI setup. So it basically builds everything on Linux and then runs actually FreeBSD binary using this. And actually, I went a little bit further. I made a little Docker image which has like FreeBSD binary in it, all FreeBSD Vault binary. Essentially, you can use it as a base to build something like FreeBSD running on Docker. Yeah, so stuff for the future, like upstream stuff, more system calls. No issue with Golang runtime for some reason not working. There are some people trying to concoct with the patch, but have not heard from them since. And we also got like first pull request recently, so pretty good. If you have some curiosity or time, check it out. Maybe you have some use case, let me know, or have some ideas how to put it forward. Yeah, so that's my spiel. So any questions? Threads support? Oh, everything works because threads actually, I didn't expect it, but threads actually needed for the linker. Right now, the linker that we use is based on CLang, right? LLVM. So it uses, it actually uses threads pretty excessively. So yeah, I had to make it work. And yes, but works. I mean, I probably some edge cases might not work, but enough for basic stuff. Yeah. All right, thanks, guys. Yeah.
Hi, everyone. So I'm Kayla Pawel. I'm a senior at San Francisco State University, and I participated in Google Summer of Code 2025 with FreeBSD with Warner. So my project was ACPI initialization and loader with Lua bindings. So the situation that I was tasked with, so ACPI provides the interface for evaluating device nodes, but ACPI is in the kernel space, it's not in the loader space. And so the problem essentially is that the loader is having to guess about the state of ACPI. So we have two solutions. We could rewrite the specification for evaluating device nodes, or we could bring ACPI into the loader. So I don't know if y'all have seen ACPI, but it's a little gnarly, so let's bring it over. Concerns, of course, ACPI is a large set of files and we're in the loader space, so we want to keep it as minimal as possible. The loader is a completely different memory space, and of course, architecture compatibility. So my response to that was I did a dependency analysis graph. I subset ACPI by 12.71%. I pretty much removed functions that the loader either could not perform or was unnecessary to what the loader needed to do with ACPI. And then we don't need to pass information out of the loader. We just need to evaluate and read the information. And then ACPI has methods for handling architecture-dependent code. So then we have the next part of it, which was Lua bindings. So that was bringing ACPI one level higher. It's kind of hard to see, but essentially this is a loader interpreter, and you can perform these commands in it. You can walk the entire namespace, print it, evaluate, and then do what you need to do with that information. And you can also assign messages to the device nodes if you need to, too. So future work, we're going to be doing ARM64 compatibility next. And then I also want to extend the Lua interface a little bit more. I want to be able to, because right now all it does is walk the entire namespace, but ideally we'd want to specify specific devices or specific states. That way we could reduce a lot of that boilerplate. And then I'm moving to questions. I have a QR code if you guys are interested in the work. I have the wiki page on it, my GitHub work, my write-up about it, and my LinkedIn. So if you guys are interested in reading more about it or getting in touch with me, I'm also open to suggestions. If you guys have anything that you need out of this work, I would love to hear that too.
So I do actually have a little bit of time for questions because y'all are behaving well. Y'all are sticking to your time limits. So if anybody has questions, we got time. Adrian had to run home. Oh, sorry, Max.
Hey, thanks, interesting work. So what are the use cases for this? I'm just curious, what do you want this to use for? Thanks.
Yeah, so essentially whenever the loader is deciding what to do to set up the kernel, it needs to know what is in the computer and what's the state of all of that in order to load the kernel. And essentially it's having to perform guesswork right now because it can walk the tree, but it can't evaluate those device nodes and know what they're actually doing. So this whole interface provides the ability to evaluate those nodes and make informed decisions based on that. So it reduces crashes, it reduces guesswork, it reduces bloat, essentially. Does that make sense? Mm-hmm.
The biggest use cases that I have is for the serial port, passing the correct one to the kernel. When you're able to evaluate it in the loader, you can pass it in, and the kernel can't look at the serial port or ACPI to find the serial port early enough, so it solves that chicken and egg problem. I'm sure there'll be a bunch of others as well. So that's when I knew she'd done it right, when I was able to do that. So
it's all about the consoles. At least in EFI, it's consoles all the way down. Any other questions?
Yeah, so what was the most difficult challenge that you had, and would you like to go into that so we can kind of learn about your experience?
Yeah, so there were 3 key technical problems that arose. I think the hardest one was definitely dealing with the general protection fault, especially since it was a space that I haven't been in before. So, because essentially what was happening is you run the loader and you get like barely any chance to see the output. So then you're like, what's happening? Where is this crash coming from? So then I had to learn how to redirect that output using QEMU so I could actually see the output without it just like blinking away. And then once I had the output and I knew what the instruction was that was it was failing on, then it was like, well, what does this mean? I don't know what this means because I've never been in this space before. So I tried GDB because that was like the first thing that I thought of. And essentially it was telling me every time I ran it and I was trying to do the breakpoints with it that it was a different spot every time. So then I tried to, once I like saw these like functions that it was failing on, I added print statements into ACPI all over the place to see where it was stopping. And then that didn't really alleviate the issue because again, it was like, this function is failing. No, this function is failing. So then I would like add print statements here and then print statements there, but then that didn't really like lead me to the source of truth. So that was when I was just like, can't I just read the freaking binary and it tell me where it's like stopping and where it's failing? So I calculated the offset from with the RIP instruction and did an object dump of the loader binary and then used that to find what function was failing. And it was the same function every time, the same instruction no matter what. And that was when I knew that was the failing point. So that was a pretty long process. I learned a lot, but yeah, that was definitely like the hardest challenge, I think. Mm-hmm.
So which function was it?
So in the ACPI specification, one of the OS functions that you have to write yourself, I was passing the RSDP incorrectly. I was passing just the raw physical address, but it actually wants the RSDP structure itself. Yeah.
Sounds right. That would be a sad day.
Yeah. Anything else? Okay. Thank you.
Thanks, Let the wiki page. Oh, I think if we go to the next slide, I think it's John Mark to talk about KExec. Yes.
So I'm actually presenting some work that is done by Justin Hibbets, who's a coworker. I'm John Mark Gurney. I'm a PE now at HPE, which was recently acquired Juniper. So you probably know us better as people who've worked on Juniper. So KExec, what is the problem? One of the big problems with booting systems is that some of the large systems can take 10 minutes, but even the small systems can take a minute or two just to do the post memory initialization, initialize hardware, all of that other stuff. And so if you're trying to do quick reboots like an ISSU upgrade of your server and trying to minimize downtime, you want that reboot to happen as quickly as possible. So that's the main problem. There's already existing prior art. Linux KExec already exists. It does the dynamic load of the new kernel, jumps through it just as a fresh boot. There's a limit to how many memory segments Linux KExec does. Right now it's 16, and the FreeBSD copied that, but that's thing. The existing projects that are using Linux kexec are Petit Boot, which is targeted more for the PPC and ARM64. Linux Boot is probably one of the more famous ones, and I know Werner, we were talking about some of that stuff as well. And then the FreeBSD kbootloader. So originally, some of this was done also for the PS3 in order to get FreeBSD booting on the PS3 and the PPC side of things. So basically, this is an overview of the boot flow. So the up top is the standard boot flow where BIOS does all the initialization, then loads our loader off the disk or wherever, where it stages the kernel, then it does the boot, and now we're running in the FreeBSD kernel. So the Linux using there's already support, like I mentioned, for booting FreeBSD from Linux using kexec, using the loader, let's see here, what is it? There's a loader version for that, and loader kboot. And so in that case, you're running Linux, then you run loader kboot, which is an implementation of loader that's running in userland on Linux, that does all the stuff that loader normally does, loads up the kernel.
Probably my screensaver. That's annoying.
No, okay, it's something else. There. Okay, let's see here.
I stared at it mean. That's what I did.
Yeah, I don't know. So yeah, so the Linux kboot does all the loader things, does all the preload segments, kernel loading modules, loading the kernel, looks at, and it presents a very interesting thing is because instead of the disk devices, you're looking at Linux file system to load kernels and stuff. And then after that's done, then it does a kexec, which basically shuts down Linux, disable interrupts, and then actually uses a trampoline to jump into the FreeBSD kernel, and now we're running. And so the FreeBSD version basically does the exact same thing, where we now have loader fkboot, which does all the loader things, but compiled for FreeBSD instead of Linux, and then uses the same kexec call and does all the usual stuff. So don't think I need to talk too much more about that. So as I mentioned, FreeBSD kexec, it follows the exact same Linux API. We're trying to make it generic, but currently so that it's not restricted. But of course, right now the only main use is to actually boot FreeBSD from FreeBSD. As I mentioned, we're significantly reused the kboot loader kboot code that was already, but just did the additional work to port it over so it runs on FreeBSD. The kernel parts have already been committed as a set of reviews. That was reviewed by various people, but so that means that all the kernel kexec syscall exists. AMD and ARM64 are supported. No other architectures are supported. And right now, Justin Hibbets is working with Werner to get the loader parts, the userland side of things, functional and properly matching, so it makes sense. We have it working internally, but as we all know, it takes a little bit of work to get stuff committed upstream and more general. One of the big issues that we ran into with FreeBSD kexec, and was actually one of my first jobs at Juniper, was tracking down, was not all drivers are ready for kexec because they don't always shut down their interrupts, they don't always shut down their DMA engines, and we may try to call the shutdown, but if the driver doesn't do it, the hardware keeps on DMAing into random memory. So it can overwrite your new kernel or your basically your root file system and that sort of things. And so that was one of the main things I had to track down. So it will take a while to stabilize and make sure we find all of those device drivers that are misbehaving or whatever. So. And apparently I gave you the one where I don't have my thank you slide. So any questions? So just as a reminder, I'm JMG at freebsd.org and now JMG at hpe.com. So if you have any questions.
About the drivers, more of a comment than a question. So when I was working on some drivers in Beehive, which were passed through, I found that some devices will not attach for a second time. They need the hardware to go through this. So as we start using that, we will start to discover many bugs like that.
Yeah. There's all sorts of things. I mean, there's also the other classic Wi-Fi driver that needed to boot into Windows first, and then as long as you warm booted, it would work under FreeBSD. But if you ever did a cold boot, you couldn't. So there's both sides. So, all right. Thank you.
Thanks.
Who knows what is this? Who is participating? Less, much less. Okay, so the idea came exactly 2 years ago at the same event. Well, it came earlier, but I announced it, suggested 2 years ago, and started to run it a little bit later. So for those who don't know, there were just few people, but just for recording, the idea is that on the FreeBSD current, we also try to make it more stable than it used to be in the past. And every last week of a month, which is defined by the week that has the last Friday, we'll automatically create a tag, and everybody who participates is advised to try this tag as update point. Be it your laptop, be it your desktop, be it your home router, home server, or the same at your work. They try to run your platform, your ecosystem on this tag of FreeBSD current. And as everybody do it at the same time, we are saving our time. So if there are some regressions, we will discover it quickly, and we all will focus on fixing them and quickly resolve them. And those who run current, they will stay on this tag until next month. Those who are having at their work running some product on FreeBSD, probably they run on FreeBSD stable or FreeBSD release. But we all understand that in a couple of years, you will be switching to next release. So it's a good point to routinely at some cadence try out your product on FreeBSD current. And the stabilization week points are a perfect thing for that. And if the stabilization weeks fails, which means that we are suffering so much pain trying to stabilize this never happened. Then at the Friday we declare it done anyway, because what I forgot to mention is that the developers are advised not to commit substantial changes during the stabilization week. There is no literal block on the repo. There is no punishment. It is just strong recommendation. Please help other people who participate in the week. If you got something big, keep it for a couple days. If you really want to type git push, you can work on documentation or you can work on bugs. This will yeah. So what button do I push? Okay, cool. Yeah, so some statistics. So as I said, 2 years ago we made this to happen. I started to do it in the beginning of 2024. So 22 times we did that. In average, we have either 0 regressions or 1 or 2. One time it happened that we had 3 regressions. Sometimes it's hard to judge what is regression, what is not. So regressions means regression for somebody who participated in the stabilization week. If you didn't participate and you discover it 2 weeks later, it doesn't get into these statistics. In general, except maybe one or two, it was mostly painless for laptop users, even when things were broken, because so many people, no, not so many actually, 10 people already makes a crowd in this situation. If everybody having this problem, it's very quickly identified and the solution comes very quickly. You're not alone if you, this is what makes it different to randomly trying FreeBSD current. And of course, the main tester of the stub weak points was Netflix. So at Netflix, we basically merge FreeBSD to our fork, which is called Open Connect firmware. And right on the Monday of the stub week, we start big testing on a large cluster of machines that at the end, by Tuesday, it gives a very strong, confident statement that this is stable and there are no performance regressions as well. Not only stability regression, but also performance regression. But there is one caveat. At Netflix, we test only those parts that Netflix cares about. So we don't test drivers that we don't use. We don't use protocols that we don't use. We don't use facilities that we don't use. Yeah, and if everything is well at the AB cluster, I will check my laptop, my desktop, my home router. I will check mailing lists on anybody else complaining. And if everything is clear, I say regression week is done. And most of the times this happens by the Tuesday evening by Pacific time. So in Europe, that will be middle of the night. Quite often it happens on Wednesday, and just 1/3 of the times we go past that. And actually, couple times this happened, not because stabilization was difficult, but because we had some internal issues at Netflix. The cluster was busy with other tests. So we started our test on Tuesday instead of starting on Monday. So even these statistics are a little bit skewed to the worst, while actually everything's good. So now I want to make one proposal, and if you all agree, I will also share the proposal on developers mailing list next week. And after that, how many minutes I got?
We're well ahead of schedule, so you got a little while.
A while?
Yeah, well, you got at least another 5, 6,
cool.
7 minutes.
I want to ask questions from you. So what can we do better? How we can improve? So I want to turn this a little bit into discussion rather than my report. So the proposal I want to make is that right now the tags are made by my script that runs on my personal machine and are pushed to my personal GitHub. So a number of people already asked me why this happens, why it is not official, and where can I find, hey Gleb, you are referring to a tag. I don't see this tag. So what I want to do, I want to run the script on the maybe freefall or maybe some other on the CJIT and push the tag to the official repo. And we can, as the tags pile up, they actually don't take any space, but there is no git bloat because of tags. So I was super conservative, not putting tags at the very beginning, but some people didn't like my idea, so I decided to go this way. But today I think that we should push tags, and probably when .0 release goes out, we will remove all the history tags. So for example, right now, if we had stabilization weeks in the era of FreeBSD 14, we would probably delete the FreeBSD 14 current era tags. So that means that the tags will stay for 2 to 4 years, and then that will be deleted. Yeah, that's it. Let's turn into the discussion.
I don't see any reason why not to put it a top-level file just stabilized in main, and always put the most recent one, so head-1 gives it out, and you have a history. If this one wasn't stable for my home use, even if it was for you, I'd know the next point I might want to try to sit on for a while. And I like the history there by it being an actual commit. And then, sorry, and then RE would just delete that when stable, whatever's pulled, delete the file because it doesn't apply to that anymore.
I totally forgot to add this to the slide. There is a wiki page that has all of them. So if you go to the wiki.
Well, but also making them tags means that it works with the VCS. So you can get cherry pick as labels and things. You don't need a separate file, just make them tags.
Wait, is it going to retag or each tag is a different?
Each tag's its own name. One suggestion I would have is to actually have, in addition to like stab week / whatever the date pattern is to maybe have like a stab week that like is whatever the last good one is, and you can do like fast forward, move the tag along.
So there is one moving tag, and
that might be because some people might want to do if we have that might encourage people who want to periodically test on head. Yeah. That what they would effectively do is they would always jump to whatever stab week is, and they wouldn't maybe test every week, but maybe would at least get them testing the same checkpoints, on whatever schedule they do them. That's one suggestion I have.
Yeah. So this suggestion brings us to one thing that I considered back 2 years ago. That okay, we got 2 regressions. These 2 regressions were addressed by 2 commits. So how do we refer to a stab week that is over, that somebody grabs the stab week plus the fix? So right now this is not addressed in any way except that you go to the wiki page and you see that okay, there were 2 regressions. You need to cherry pick that. So the question is, do we want to run this short-lived branch or not? Or if we are sure that other commits that came in during Tuesday, Wednesday are fine, maybe we should just move the tag to the last fix. So I don't have answer to that yet.
Yeah, I think that one's a developer's question is my guess. So I can imagine opinions on like all 3 possibilities myself. You could have another tag, but what I think
like a second.
His question though is the tag, let's say you but the question is, what are you tagging? Are you making a new branch that just has the 2 fixes on top of the original tag? Or are you tagging some point further down main that has 2 fixes plus 75 other commits?
We don't have capacity to rerun the test. That's the thing.
Yeah, because people are going to just run the test and report regressions, and then what tends to happen on the mailing list when people report regression is they say, "Oh, I have this bug," and we find out, "Oh, the fix is here," and they say, "Yeah, I tested that patch and it fixed it." So people, the thing they tend to effectively test is the tag plus the fixes. But if we do that, then we're carrying extra hashes in our history because those are not the same additional original commits. It's probably very cheap, but we would need to make a conscious decision if we want to have these extra branches around that, I mean, and they never go away, right? To some extent. I mean, I guess if we delete these tags at the end of the .o, at some point you'll prune and they'll go away.
Yeah.
So maybe that's okay.
They will be pruned basically when the .o release becomes historical. So for example, right now we have no interest in the stabilization tags of 14. Yeah, Simon, and this thing, even if we had capacity to retest, it also has a risk of a live log, and so that you retest and discover a new regression, and you need to search for this regression. This, how you said, 75 commits. Yeah. So before at Netflix we started working with this cadence, we were doing pretty much the same, but in a relaxed schedule, like. Okay, about a month have passed, let's try that. And a couple times we were caught in this loop that yeah.
Finish your thought, it's fine. We're ahead of schedule, it's okay.
Okay, any more suggestions? What can help you? If you're not using stub weeks, those who didn't raise their hand, what will help you to start using them?
My more comment is just about what we were just talking about. I would actually encourage sliding the branch for stability instead of just doing a twig off that, because the whole point of some of this is to be testing main, and so staying on main, even if you get 75 other commits, you're now testing those 75 other commits. It may be less stable, but the whole point is to be testing main.
So you will vote for a short-lived branch?
No, I vote against it.
Against it, okay.
Yeah, I'd vote for sliding the tag further along main. It may not be as stable, or maybe we do something else. But the point is that we're expanding the testing. That's just my gut feel. So.
If there are regressions, well, that means that. Yeah, you check the stub wiki page. You will see that most of them will be deleted.
So is the point that the sort of the top level golden tag, right? Like some of these projects have had like a golden tagged release or a golden branch where they merge over when things are passing. Is that the goal, that that's going to be sort of the tagged version that everybody can just pull from and sort of assume that it's past some level of testing, that we should be working off of head from that?
Yes,
yes. If that's the case, also I wonder if it's easier to help with doing, some kind of binary release and upgrades, if that's not like too crazy to add to the infrastructure.
I hope that the snapshots FreeBSD org will be using these tags as snapshot tags.
Yeah.
This didn't happen yet. I don't know why. Who actually runs it?
So logistically, we never can delete a tag. We never can move a tag. It has to be new tags. Any solution has to take that into account. So we're not ever going to delete a tag, and we're not ever going to slide a tag. But we can have a new tag and have a hierarchy of _1, _2, whatever. But just a note for the solution space has to take that into account.
Yeah. There is a flaw in Git. It's not trivial, but yeah, we cannot slide the tag. We actually can delete it, but for many people it will be not deleted. The branch is better.
Just so you know, I'm now doing the weekly snapshot builds of main starting at midnight UTC on Monday, which is not the same time as I'm doing the snapshot builds of the stable branches, which is midnight UTC on Thursday. I have 3 build boxes available to me, so 13, 14, 15, and 16 does not fit onto 3 boxes. So main got moved to Monday, which I think lines up better with the beginning of your stab weeks as well.
Yeah, I'm doing it at 8 GMT.
I can adjust the time. So we should just talk and coordinate when we want it to happen.
So again, anybody to raise your hand who doesn't like my idea of making it more official? Very good. So I will write email to developers to sum up what I suggested, and and we will work on make it more official.
This might have to be the last question, though.
We can't slide a tag because it would be a forced push, or is it the? I'm sorry. Okay, it's not a FreeBSD limitate.
It's more about, do people believe the slide tag?
Yeah, Brooks, I was just like you, but actually Warmer showed me proof. There are pitfalls in that. That's a real flaw in
Like
Git.
you have to make sure the tag gets to GitHub, for example, or GitHub mirror, that it stays up to date. And then everybody's, I can understand why it's a pain in the butt.
Warner will demonstrate that. That's true.
Anyway, I think the hook. Time's up. Actually, Michael's next to talk about. I didn't ping him yet. About BSDCan.
Colin, would you like to join? Please join. The screensaver was beautiful.
Yeah, that's what I'll give you.
Cool.
But you can get started.
Okay.
I'll close in a second, sorry.
Cool. Hello, my name is Michael Dexter, and I wear many hats like many of you. And this is Colin Percival, who just shipped 15 Beta 5 between lightning talks. Congratulations. And here in spirit is Alan Jude, who's hopefully waving from past a security line at a nearby airport. And we represent the BSD CAN finance team. We have the most terrifying job in the conference. Officially, BSD CAN 2026 will be June 17th through 20th. And the call for participation is open. It was opened in Zagreb at EuroBSDCon. And masks will be suggested but optional. Now, beyond the official, events are priceless. Here we have a beautiful view of Canada from the coast. Venues are hard. Streaming is hard. Food is hard. So if anything, thank you, NetApp, for this venue and your sponsorship of this, because we know how hard venues are, rest assured. Thank you, streaming crew. I see people in back invisibly making the magic happen, and the food crew. It's critical. We all got to eat. Those things all happen, and they make for priceless events. And we all have a low price of entry, maybe $100, $300 to get in, and we have priceless memories and conversations and talks and exciting stuff. And beyond that cost of entry, and what you see is just magic behind the scenes. But that magic is often a whole bunch of hard work by a bunch of volunteers. And I see many sponsors of BSD CAN in the house. Thank you for that, because without that magic beyond the retail price you see on the ticket, there's no event. Without all your help with connections and technologies and you name it, there are no events. So I love events like this. They need not be big. BSD CAN is the big one in the community, but these are both equally valuable in my humble opinion. And basically, thank you. Quick show of hands, has anyone been to BSD CAN or, wait, not been to BSD CAN? It's like, okay, the two new contributors, welcome. So, the CFP is open. We do hope to hear more about the things you described in lightning talks, etc. Anything from your side?
We will hopefully have travel grants, which may help some people to make it to Ottawa. Ottawa is relatively cheap as far as cities go that have conferences. The accommodation at the university in particular is cheap, and as far as university accommodation goes, remarkably good, actually. But yes, we need money to run the conference. The registration fees more or less cover the food. They do not really cover the facilities or paying for all the speakers to travel in. So really, it is sponsors that make the conference work financially.
Any questions? And I'll go there. So being on the West Coast here, I personally have my heart dreaming of a BSD CAN in Vancouver, and housing costs are much higher and we'd have to subsidize them. But I'm hoping that those here who might have like a 2-hour flight instead of like a 5-hour flight across the country might find that beneficial and might find that something to explicitly sponsor. Show of hands, would anyone present seek a BSD CAN that ping-pongs between Ottawa and Vancouver, Canada? Hand, 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 hand. Cool. Talk to us both about offline about that. It's a dream, but I'm allowed to dream. Thank you. Thank you, John.
Thanks, Mike and Colin. All right. I actually have no slides. Well, I have slides for the closing that's coming up. But I put myself on the schedule for a lightning talk, and I'm going to do 2 oddball things. Well, one of them is not odd. First, I have a query. This is something we ask in our user survey, but this is a different audience, perhaps, in our user survey. And so there's some information I think would be useful for us as a project to have with some of our planning going forward. So what I'm going to run through is all the different architectures we currently have. And what I want to know is if you are planning to use this given architecture in about 2 years' time. In particular, you're planning to run FreeBSD 16 on this architecture. So who thinks that we'll be running FreeBSD 16 on a 64-bit x86 box of some sort? I think this is an easy one. How about a 32-bit x86 box? Not the same thing as a 32-bit binary on a 64-bit box. Okay. How about a 64-bit ARM machine? I guess actually I have one of those now. I guess Murillo counts. How about a 32-bit ARM system? Okay. No judgment-free zone, just data. Just data. How about, just going mostly alphabetical order, 64-bit PowerPC, either big Indian or little Indian, and 64-bit RISC-V. Does it get cheap enough? Or they're in sand, yeah. Maybe, okay. Thank you. That was the first part. The second thing that's my actual thing on the wiki schedule, one of my current projects for one of the folks I'm working with is working with our OFED stack, which is used for both InfiniBand and RDMA in the tree. It uses the Linux KPI, and it's kind of an import from Linux. But our current OFED stack gets sporadic updates. Part of this is that our last active maintainer of the OFED stack was Hans. And so that's kind of among several of the holes that Hans left. That is one of them, is kind of helping OFED to stay up to date. In my current work, I'm trying to cherry pick commits back from Linux. All the bits, the core bits of OFED are all dual licensed, so this is all perfectly fine to do. And I'm slogging through that. One of the things I found is we have some newer drivers in the tree that use OFED bits, in particular for Rocky support, such as from Broadcom and Intel. And each one of them duplicated their own little compat shims to make up for things that weren't backported from OFED. And so part of what I'll end up probably doing is removing shims because I'll be deduplicating the work that they did inside the driver instead of over in the common OFED bits. So is anyone else in here interested in RDMA and OFED sorts of things? Because I'd like to coordinate what I'm doing. In particular, I'm going to need help testing on other NICs. So no one in here? Okay. But maybe I'll find someone on the mailing list. I know I already have one open mailing list thread about it, but I thought I would ask about it. So that's my one lightning talk. No slides for that one. So with that, now I can actually go to my slides. If I can get my mouse. Oh, that's right. All right. So we've reached this time. This is the conclusion of our two-day conference. So I just had if I'll turn my clicker on, a couple of things to go over as we're wrapping up. First of all, the folks who've worked on organizing this conference, we would love your feedback about things we did that worked well, things we did that could work better. So we have a survey prepared. There's a link right there. There's also a QR code. And also when we're done, I'm going to leave this on the end of the screen. But go ahead and get started if you like. We would really appreciate your feedback to help us to continue to improve in future years. We have several conferences upcoming in that are in the next calendar year. We talked about this in the opening, but I'll talk about this again. Our next one coming up is Asia BSD Con, which will be in Taipei in March. And Lee Win emailed me today. He wanted me to remind everyone that the CFP is open through the end of November for proposals for talks and tutorials. And if you have any questions about Asia BSD Con, you can email the organizers. I think the address is committee@asiabsdcon.org. As Michael and Colin already talked about, BSDCan is then next on the calendar in Ottawa in June, and the CFP for that is also currently open. And then lastly, EuroBSDCon will be in Brussels in September at the end of close to the end of next year. So that's the next three coming up on our kind of project calendars. As Michael alluded to, these events, that we all pay attendance fees, but we also get a lot of generous support from our sponsors. So our first sponsor is NetApp, providing the venue and AV resources and logistics and food and all sorts of things. We also have the FreeBSD Foundation as a sponsor providing some of the finances and other logistical support as well. And then there are several other folks I would like to thank. So if we had no speakers, then y'all would all sit in a room, and I'm sure we'd have a great long hallway track for 2 days, but at some point, you run out of things to chat about in the hallway. So it's having people who are willing to talk and kind of be up here in front of everybody and you know, be speaking, that really helps. So I appreciate all our speakers. Thank you for putting time in to prepare a talk and to present. On the other hand, if you're a speaker and you've given a talk, if you've ever had to give a talk to an empty room, that's not a lot of fun. So you being here and participating, listening, like giving, you know, whether it's your kind of body language response and cues, asking questions, participating in the conference or in each presentation, that's also very valuable. So thank you all for being here and attending in our conference. As many of you have already noticed, there's also a lot of stuff going on. We have folks in the back who are managing our audio and managing the screens and so forth, as well as our camera operators and live stream operators. And Scale Engine has helped out as well on the video side with helping us with our streaming. And then lastly, there are several of us who work together in a committee, both working on BSD Canvas Dev Summit and this Vendor Summit, and we meet every week. I think now we'll get about 2 weeks off, or maybe we'll get a month off before we start planning for Canada. But we have weekly meetings trying to, you know, cajole and encourage people to come give talks or figuring out, you know, how working with each venue to figure out catering and so forth. So thank you to all the folks on our organizing committee who help organize and make this conference happen. All right, so that's all that I had. So thank you for coming. We'll see you again next year or in Canada or Taipei or Brussels. That's it.